So root is less. Container networks get in shape with pasta. Yeah, great. Okay, good. So this will be about container networks, well, presumably rootless, as you might have guessed, and pasta. So what is pasta? As you might have guessed, I'm Italian, but I'm not talking about that. So let me show you something. Right, here I am. I'm on a server, and I do this, and I'm root. And let's take this server down. Am I really root? No, I'm not root. Right, so great, luckily. What's the trick then? Wait, it didn't get through. Did I just reinvent unshare, and I'm just so enthusiastic to show it to you? So okay, let's try to understand where I am. And the good thing sometimes is to look at networks or network interfaces. Okay, so I have loopback, and I have another network interface, but it's down. So how am I here? I mean, this makes no sense, right? Okay, let's get out of this madness and go back to my host, have a look at what I have here. Okay, that makes more sense, right? I have an Ethernet interface, state is up. Looks similar. So, okay, the MAC address is different though. And it's not the same interface because one is down and the other one is up. So, okay, I read the man page for you. I actually wrote it too, but, and I will now try this. And I will check addresses I have into this strange root, no root thing. Oh yeah, no, okay, great. So this is up, or at least administratively up. The state is unknown because I didn't send any packet yet. I have some addresses, IPv4, a bunch of IPv6, link local. Great, okay, this starts making more sense. And let's see if I can reach the internet. Sorry, we talked about pasta, so yeah, great. So IPv6 is up, ICMPv6 is up, DNS resolution was working. Okay, so did it just re-implement Podman? No, because it's full of stuff here, and the container will be clean, right? I just started it. Okay, so let me quickly explain the trick to you. And note that I'm really not root. I'm really, really not root. Okay, I can't delete one thing from here. Sorry, ls, I can probably do it, but let's say I want to, bash. Yeah, nope. Right, so no, I didn't re-implement Podman, and in fact, Podman can also use this thing. Let's use Alpine, right? Sorry. Okay, and let's have a look at this. Okay, pretty similar. So the interface is still this strange name. Well, that was the interface on the server. I have the same addresses. Let me check that this works. Yeah, I can install iPerf3. Great, so this seems to be some user mode networking. And before I finish revealing the trick to you, I just mentioned user mode networking, and it might look like I'm copying packets from user space and back, and this is terribly slow, right? I mean, somebody probably played with Slurp. So, Okay, let me go back to my strange tool here. Actually, sorry, let me run a hyperserver first. So I demonize it so that I can just keep a big terminal here. I hope you all see here, or is it even? No, it's okay. Great. So, and now, how do I reach that? Well, it looks very local. I will try with localhost. And I'm being quite arrogant, come on. I know that it's fast, and I can give it 32 megabytes of TCP window and 0 copy and disable Nagel algorithm. Right, maybe, look, even, let me do 2 flows. Great, 60 gigs per second. So, right. Okay, now I can reveal to you the trick. So, I'm not root. I created a network interface, and this thing is pretty fast. Let's look at some diagrams. What's the trick? So, how does networking work when you are nobody? Or, well, in my case, you are as preview, but it doesn't make a real difference. So you don't have root. I don't have capnet admin, right? I didn't show you, but trust me, I didn't cheat on that. So I cannot have interfaces. But Linux allows you, if you detach your user namespace and the network namespace at the same time, since Linux 3.8, which is a few years ago, like 5-6 years ago, I think. At the same time, we can actually create a network interface somewhere. So we can actually create a network interface because we are UID 0. So we are, you might call it root for convenience, but that's not root. That's just UID 0 in a user namespace. And UID 0 can do a lot of things, like creating network interfaces. Oh, and there is the TONTAP driver. It's a kind of old implementation, but quite useful. This thing creates a network interface on one hand, and on the other hand, you have a file descriptor. It's not a socket, it's a file descriptor. So sockets can be represented by file descriptors, but it's not the same thing. And on these file descriptors, you get frames, and you can write frames, Ethernet frames. So the whole thing, you know, like it go on a cable. You don't have it here, so it goes, oh, no, it goes in the air. Right, and then we know that regular users can open TCP and UDP sockets for sure. I mean, when you start a browser, you don't do sudo Firefox, right? You just start it. So, are you thinking what I'm thinking? If we do this. So, we have the network namespace. We just created this top device, which gives me the Ethernet interface inside that. And down there, I have the internets. And then I know that as a regular user, I can do TCP and UDP sockets. I just need to fill in that something. I'm not saying that it's so simple, but starts looking doable. And that something, namely, needs to take the Ethernet frames away, take the the Ethernet header, the IP headers away, put the payload into layer 4 sockets, and then I think we are done. And when we get something from the internets, we need to ask the kernel. So this something is a user space application, and we need to ask the kernel, where is this packet coming from? And then tell our network namespace. And we have a number of ways to. So we have 2 addresses essentially, right? So just reminder for everybody. Layer 1 is the physical network, physical layer. Layer 2 is something where you can put bytes on, right? The data layer. So, and then you have layer 3, which is IP, or can be other things, but in our case, it's IP. Layer 4 is a transport, so TCP, UDP, ICMP, TCP, whatever you want, and then the other layers are more related to, YouTube. So, great. And why am I doing this? So what's the whole point? No, because we can actually. Yeah, also because we can, otherwise we wouldn't be doing it. But the important thing here is that I don't have root, I don't have capnet admin. So if I'm doing a container like I just with Podman, and somebody hacks it because I didn't apply security patches, or because I'm dumb and I just map ports without authentication or something, well, I have no embarrassing consequences, or limited embarrassing consequences. No, it could be much, much worse. And let's say, even if nobody does that, we have the safety that what a user can do is just open and connect and bind to TCP, UDP, and ICMP ping, so the so-called ping sockets. So that means I have the safety that nobody will spoof packets, because if you can send arbitrary frames, like if you can spoof ARP, you are in control of a network essentially. You are telling everybody, this is me, and this is him, and this is her, and so that has serious consequences if you can do arbitrary craft arbitrary frames. And it can be quite fast and also flexible now. So I would start saying that it looks like a good thing. So what would have been the alternative? The alternative would have been that I went there to my server and I created a container, and then I would have done IP add something, created a bridge, did something with NetFilter maybe, just to drop a bit of the really suspicious things like ARP frames that come out with totally random MAC addresses and stuff like that. But that would have involved that I needed root. And I realized there was a talk about that actually yesterday. So I want to also state that this is a limitation for some applications. Maybe you're really running ARP proxy inside a container. If you want to do that, hey, you need root. But then there is a good reason for it. And OK, that's an ugly workaround, right? I mean, I'm appending frames, appending headers, removing headers in a user space. So you're going to fix it, right? No, I don't think so. I don't think there is something to fix. So there are reasons why this is not allowed. And I mentioned some of these reasons. So, right, I mean, an unprivileged user shouldn't be in control of the network as well. So this is kind of, there are many ways to divide unprivileged and privileged user. That's pretty much the Linux and BSD way. Other operating systems do completely different reasonings. I heard of operating systems running a UI at ring 0, but Linux luckily doesn't. So, and OK, let's say, like in the talk yesterday, we do it for them. But are they really unprivileged then? I would start having some doubts. So I think that if a network interface if a network namespace like we did as an interface, then we should follow that philosophy. OK, it doesn't have root for a reason, and we should stick to it. Because, yeah, these are the few advantages. We really don't need to even debate whether it has privileges or not. And actually, yeah, implementing appending headers and removing headers is a way of ensuring isolation. We are in control of this, and we check that the kernel forces us to append those headers as we send packets out from the bottom of the diagram, right? So when we are there on the layer 4 sockets, the kernel doesn't allow us to put an IP address and a checksum there. No, it says, I do it, I take care of it, I don't trust you. So that's how you implement isolation. I cheated a bit in the demo earlier, so we were actually in the left case, so I didn't do so much in that thing, because yeah, I used a local connection in the demo. It's a bit easier. And in that case, I already have layer 4 sockets, because I am doing a connection from iperf from the container to the host. Well, host is a bit of a misnomer, right? But it's still the same host. It's a different partition of the host, so to say. And there I already have layer 4 sockets, and I can just splice data. Splice is a system call in Linux that just allows you to splice to a pipe, from a pipe to a socket, then from that socket to a pipe, pipe to socket, and you don't need to do anything special. However, of course, we are just carrying payload there. So that means we have no addressing, and that means I can just use the loopback interface to do that. So if we are actually to the we want to go to the internet, we need to do this trick that I was mentioning earlier. So we really need to append headers, remove headers. Otherwise, so if somebody's familiar with the Podman situation as of a while ago, there was a way to be really fast with this trick, and with some amazing tricks. On the other hand, you would lose the IP address from outside, so all the traffic would look like it was coming from the host, and that's not so convenient if you have applications inside there that need to, for example, authenticate based on IP address, or filter, or route. So, okay, now we pretty much got, so this is pasta, okay? That's not the thing you eat anymore. That's something in between. The acronym, I don't even remember it. I mean, if you want, just go to the website and it's written there. So we got what it does. I just wanted to present a few peculiarities that makes it, in my opinion, reasonably safe. So we don't do dynamic memory allocation there, and funny because we are dealing with packets, so it would be natural to read from a socket, allocate 1,500 bytes or a bit more, then free it when we send it. Now, if we are careful, the kernel has already buffers, so we can use them. We just need to avoid dropping things from kernel queues before it's time to do so. So when I get a packet from the socket, I need to remember that my container needs to read it, and maybe it loses it. Maybe nobody's reading it, or maybe they are too late, or maybe it's out of the congestion window because I sent too fast. So I need to keep it there. I have no other space. I'm not allocating memory. So I can use message peek. So message peek is a flag for the receive and receive-like system calls that allow you to, yeah, just look at it, don't drop it. No, let's pretend I didn't read it. And these avoid some classes of memory-related potential security issues like, I don't know, a double free heap overflow and stuff like that. It's not completely safe. I still can have stack overflows. It's a bit harder, perhaps, and it's a bit easier for my mind, actually, to keep track of the stuff I'm doing, which it's probably an important factor for security. The TCP adaptation, so there is some TCP adaptation. This thing needs to keep track of the connections. And however, we have already 2 stacks around. It's actually, in the case of a container, the same kernel and 2 instances of TCP stacks. So we don't need to do really much in terms of congestion window and keeping tracks of metrics and expanding the window, shrinking the window. How much memory do you have? No, we can ask them, what is your congestion window? Yeah, okay, I use it. It doesn't do that if you want it. If you don't want it, that's why it was so confusing, perhaps. But it can also be convenient. So we had the same addresses inside Podman and outside. Full IPv6 support, but I hope maybe we don't have to mention it in 2023. Yeah, actually, I could have just gone into this pasta config net that I showed you earlier and asked for a DHCP, asked for an address via DHCPv6 or DHCP. Did I say past? Right, yes, I did. So let me cover a bit of this project history. It's not original at all. It's a big scam. So Slurp has been doing that for 18 years, actually. Sorry, is it 10 minutes? But 15. To the questions. Okay, not to the, yeah, great, thanks. So ZLIRP has been doing that for 18 years. I'm really not presenting anything new, probably. We started it for virtual machines. Namely, KubeVirt developers came to my team and us. We don't want to use ZLIRP because it has a bad name, but it's really convenient. Can you do something like that? We want to run our container with virtual machines, that's KubeVirt, without root. And if possible, we would also like to avoid NAT. So we started it for virtual machines, and then at some point we realized that containers had exactly the same thing. So much that for QEMU, you have this libzlib. So ZLIRP comes from the 90s, right? The story is kind of complicated. I will not cover it for the sake of time, but it was a way for when universities started offering dial-up shell accounts to students or professors to have a natural internet access by tunneling everything you wanted into your dial-up connection that was supposed just to connect to your university server. And then from there, you had routing. So you could, if you tunneled everything into that, then you could reach whatever you wanted, not just the resources of the university that nobody cared about. So this is, right, that's an old trick, and somebody had a really brilliant idea, in my opinion, to use it for QEMU. And then for another brilliant idea for Podman. And there is something similar for Docker, actually. So there is something already very similar. Also, this ZLIRP for NetNS is like pasta, and libzlirp is like past. Both acronyms are available on the explanation of the acronyms are available on the website. But yeah, it had a bad name. Well, okay, nowadays you leak 50 bytes in one day and you get a CVE, yeah, fair. However, also performance-wise, it wasn't really meant for the bazillion bits per second that we need to have nowadays. It was meant to, yeah, dial up, a bit more than Telnet, post-BBS era, I would say, or still BBS era. So it doesn't support TCP window scaling, which means 64K is all you can send, and then, okay, 64K more. That's slow. IPv6 support wasn't really there. So IPv6 was actually introduced a bit before, but there was no reason to use it. We still had plenty of IPv4 addresses in the world. And right, so we realized that Pasta was born, and then with a lot of help from Podman's development team, we shipped a native integration I just showed you in Podman 4.4. That was in January this year. Since 2 days ago, this is now supported in Builder. So if you're familiar with it, that's a facility creating container that can build container images in Podman. It's supported by libvirt, KubeVirt, a stack preview. We are now very few, but very committed developers and lots of occasional contributors. And Podman users came up with everything possible. Let me cover recent developments, just in case you followed this project recently. So somebody said it's not fast enough. OK, great. What can we do better? So this only applies to VMs, so it's not really Pasta. We have a Unix domain socket to QEMU. That means copy to the socket, copy from the socket. QEMU needs to do that, and PAST needs to do that. OK, we can just bypass QEMU altogether with VHost user, and it's actually faster than, don't quote me on this, but because we don't have very nice benchmarks yet, but it's actually faster than whatever you could do with root and the bridge. So yeah, we now copy all the addresses and the routes, not just one. You saw that I had so many IPv4 addresses there because we had some problems with cloud environments, some users reported. And WireGuard almost works out of the box finally. That's a bit complicated, but it looks like a popular use case for Podman users. So these new use cases. One funny thing somebody came up with is What if I want to just have throwaway containers, deploy them quickly with their own address, and I don't tell the host anything? Interesting. With IPv6, it's actually the case. Sometimes you have a /64, so yeah. It's actually possible. So in that case, pasta would just bind an address that the host doesn't have, nobody has ever seen, except for the prefix. So you can just have a completely separate container with its own address and assign it with an NDP responder that's built into past. So we advertise the prefix and nothing else. We assign a pseudo-random MAC address. We take care of it. We keep track of it. And we could actually deploy a lot of containers without really knowing much about the network or really not thinking much about it. And some people already use MacVLAN for it. But it takes a few tricks to set up, and it's not rootless. Another less funny, maybe less visionary, but this starts being important. You have IPv4 applications that maybe you don't have a source code for, but they are IPv4, and you have an IPv6 only setup. Maybe somewhere in Central Europe, this starts being a problem. You start paying quite a lot for an IPv4 address. So there are RFCs for this, and Pasta could be a good candidate. You can find more details in the bug reports there. Another one we really need to take care of now is, how did I do port forwarding there? You didn't even see it because I didn't do it explicitly. It was automatic. And you can do it with Podman configuration options and everything, but for Docker, actually, they really need it via rootless kit. And also for Podman custom networks, it would be really nice if Podman could happily decide without stopping and restarting the container to, or Pasta itself actually to map a new port. And we are, with that, going into a generalized flows table. We don't want to implement Open vSwitch, but we are dangerously close to it. Start preparing your questions now. So if you want to try this out, please do, and please especially report bugs. We have mailing lists. We are a bit old school, but don't be afraid to mess up. We understand that many people are not used to patch-based or email-based workflows. There is an IRC channel on Libera. It's past. There are weekly meetings that are open to everybody. If you just even want to listen to the dramas we have, it's can be quite funny. And all this information, you find it at past.top. Credits, yeah, so David has been reworking a lot of stuff recently. Laurent is taking care of the bazillion bytes per second there. Paul from Podman's development team is got it into build this week, and he always helps a lot. Lemmy is a packager for White Linux, and he presented a lot of new use cases. Lane did libvirt integration, and Jon is making the kernel nicer to us, or trying to. And we have a lot of, really, a lot of contributors and packagers for, so packages are available for Arch, Debian, Ubuntu, Fedora, RHEL, a few more probably. Questions?
So when you were talking about the cheating case where they actually create the prejudice interface, is that the XC network kit or whatever it's called that is part of this kit?
So the question from Paolo is whether, when I was referring to the cheating case where I just have local traffic, I'm referring to rootless.
Not the local traffic, the one that bypasses
the tap.
Makes the privileged setup. When you say that it's fine like this, if we added more infrastructure and fix it right, it would be cheating. I think there is something in rootless kit that does it.
Yes. Okay, so does rootless kit allow, is rootless kit the part that allows us to skip the setup, to just create a bridge to the host? No, actually, so rootless kit, what it does Okay, rootless kit is a pile of things. In this case, it's what rootless kit does the trick of copying packets back and forth. Not with splice, they use receive message, send message. It's not very different, but that's the part that it does. And you have it actually as default port forwarder for Podman because it's faster, but you don't preserve the source IP address. So that's the part it does. Yeah. So first question is of two is if this can be used with Podman network commands. So as far as I know, yes, since Thursday, but you probably know better than me. And if you don't, let's check it out. But I think Paul just did this because it was I just did it with Podman run, as you've seen. And I think now finally the code has been moved to the proper place, so we can actually use it for Podman network. I think that's my understanding. Yeah. So the second question is, when will pasta become the default in Podman? You suggested 4.6, right? I hope we are on track. Yeah, might be tight, but yeah.
So when you did your experiment with localhost, is there at some point will there be a need to have a localhost that is inside the container as opposed to having a localhost that targets the host?
Wait, can you repeat?
Will there at some point be a need for being able to distinguish between localhost being inside the container, like inside my namespace, as opposed to localhost talking to the host that the container is going on?
Right, so the question is, I showed that I would connect to localhost and connect to the host, and maybe I want to really connect to localhost as localhost, yes. And yeah, actually, one of the reasons why we are reworking the NAT model is to allow to, right now we just allow to disable this functionality. So to map nothing, or to map everything, or to map like the address of the default gateway to the host. But it is not very flexible. So we are actually adding more options. And what the default is, it has to be seen. We need to check with many people, like what do they really expect? Because if you come from VMs, you have different expectations as yeah, right, yeah. I can check on Matrix. Okay, thank you.
say something?
Hello.
That
Okay,
works.
good. So good morning, everyone. I'm Stefano Garzarella, and today with my colleague Armand Maglione, we will talk about uBlock, virtual block devices in user space. So these are the main topics that we will cover today. We will start with understanding what are virtual block devices and what are users for. And then we will do a brief introduction of uBlock and IOUring, which is the main feature that uBlock use. And then we will take a closer look at the uBlock driver, the user space libraries, and some use cases and examples. And speaking about virtual disks, we will cover also the QCOV2 format image format, and also we will see how to reuse the QEMU storage feature without virtual machines using the QEMU storage daemon. And finally, we will also talk a bit about the evolution of QSD, the Rust storage daemon. So block devices are usually those devices that we use to store permanent information, and they can be like NVMe or magnetic disk. So we usually have fixed site blocks that we call sector. But in this case, we are talking about virtual block devices. So, and with virtual, we mean devices emulated by software. So why we need this? The first use case, of course, is obvious. It's virtual machines. But we can also use these devices without VMs. So because the disk image format that we have for virtual machine like QCOV2 offers really nice feature like growing images, snapshots, backing files that we can reuse also, in some use cases where the isolation is needed, for example, with containers. And another reason to use virtual block device is to mount, for example, into the host virtual disks in order to do some kind of manipulation. And finally, the virtual block device allows us to use network distributed storage like NBD, iSCSI, and CephRBD. So Linux already provides several implementation of virtual block device in kernel, and for example, the loop device, NBD, RBD, and some others. But of course, for example, for CephRBD, the entire protocol is implemented into the kernel. So an issue into the protocol implementation could be, a big issue and propagated to the entire kernel, causing panic. So for this reason, it could be interesting to move at least the protocol implementation in user space. So of course, we still need a small piece of kernel code, the module, to interface the Linux block layer with the daemon is emulating the device. But the entire implementation of the protocol could be moved in user space. So just to summarize why we need to do this in user we can do this in user space. Yeah, the usual thing is safety, isolation, maintainability, portability. Of course, we need to pay a trade-off that is performance. So, and this is the talk, the main reason of uBlock. So the idea is to try to fill the gap with the in-kernel virtual block device, because uBlock is based on IOUring, and try to use, to take advantage of the high performance of IOUring to move the device emulation in user space. uBlock was introduced by Ming Li pretty recently in Linux 6.0, and essentially is a kernel module, uBlock driver, that exposes a standard, regular Linux block device to the user space, and forward all the requests to the daemon using the IOUring queues and shared memory. We will see later. So uBlock, the uBlock driver provides several interfaces. The first one is the uBlock control character device. So this device is used to do the setup, to allocate the device and set up it. And when we created the device, then we have two new interfaces. The first one is the uBlock B0, in this case, in the picture, which is a regular Linux block device. And then we have also the uBlock C 0 in this case, that it is the character device exposed to the daemon for the, to handle the request. So essentially what uBlock does, every request that an application or a file system does on this regular Linux block device will be forwarded to the daemon through the uBlock-C interface using I/O urine queues and shared memory. So the shared memory is used essentially to forward all the request information, and the I/O urine queue is used to send exchange notification between the kernel and the application. We will see more detail in a bit. We can do like now a brief introduction of I/O urine. Maybe most of you already know, so, but yeah, will be useful to refresh. This set of slides, we already talked about that in a previous talk. I put the link, so today I will go really quickly. But if you want more information, there is a link here. So what is I/O urine? I/O urine is a Linux interface that is useful for doing asynchronous I/O. So it was introduced by Jens Axboe in Linux 5.1, and initially was focused on block requests, but then it evolved to support more and more system calls. So now it becomes like a generic framework for doing a system call in a synchronous way. The interface is pretty simple. There are 2 rings queue that are shared in memory between the user space and the kernel, and 3 system calls. So we have 2 queues essentially to avoid contention. So there is one queue, the submission queue, where the producer is the user space, the application, and the consumer is the kernel. And then there is the completion queue, but this is the other way around. So the kernel is the producer, and the application is the consumer. So talking about the system call, the first one to be called is the I/O urine setup. So it's almost allocate the memory and set up the context. Then we have the I/O urine register. It is also used only, partially in the configuration phase. So it allows essentially to register resources that are often used during the data path. So in this way, the kernel doesn't need, for example, to remap user buffer every time, and can also be used to register files descriptor or event FD and other things. And finally, the last one is I/O urine enter. This is, the main system call used during the data path, and it's used by the application to notify the kernel when there are new operations to do in the submission queue, and also to rape the completion of that operation through the completion queue. All of these things, anyway, we have a library, liburine, that is available, and it provides a convenient C API that hides all of these system calls. So now, let's take a closer look of how the I/O urine queues works and how an application can submit things. So the first thing the application needs to do when it has a new operation to do, for example, a write operation, it needs to produce a new SQE, that means submission queue entry, and need to fill all the fields like opcode, so there is the write opcode, and then all the operation that we usually use, for example, in the write system call. So the file descriptor, the address of the buffer, the offset, and other things. Of course, the application can put multiple SQE before calling the system call. So when the application puts the SQE into the submission queue, update the tail of the submission queue, and when it's ready, invoke I/O urine enter to notify the kernel. At this point, the kernel starts to consume the submission queue entry and update the head of the submission queue, and essentially store internally the information of all of the operation that needs to do. Now the kernel starts to process the operation. It can be done in any order. So there is the only way to link the SQE with the CQE, that means completion queue entry, is the user data. So the user data it's a 64-bit value. It's completely opaque for the kernel, and the application can put anything. So when the kernel completed the operation, it produces a CQE, and it will essentially copy the user data from here to here, In this way, the application can link a CQE with a SQE. And so when the operation is completed, the kernel produces a CQE, copy the user data, and set the result and flags, and updates the tail of the completion queue. Also, in this case, the kernel can produce more than one completion in one call. So when it's finished, it returns to the user space, and the application can consume the CQE, updating, in this case, the head of the completion queue. So this was essentially, I mean, this was essentially how IO-Uring works. Now, there are a lot of other features and a lot of other details that we can cover, but one of the features that I want to show you is this one. It's called IO-Uring pass-through command. This pretty recently was introduced in the Linux 5.19, and it consists of a new opcode, the Uring command, and 2 new flags that essentially allow to double the size of both SQE and CQE. So why it's useful? So the pass-through command is essentially a way to do asynchronous to do asynchronous command for special file like character device that can be exposed by driver, file system, or any kernel component. It's an asynchronous alternative to ioctls. Essentially, both of them allow to define new special command from kernel code without implementing new system calls. And now it's used in the kernel, and the first user was the NVMe subsystem that essentially used it to replace ioctls. So for this reason, can be used as an alternative. And another user is uBlock, as we will see. So in very short word, the user space used the submission queue to send arbitrary command to the kernel, and the new flag allowed to send up to 80 bytes as a command data. And then the kernel used the completion queue element, queue entry, to respond back the result in a completely asynchronous way. Now let's take a look on how uBlock used this IO-Uring pass-through command. So the first device that we saw was the uBlock control, and it provides several commands through this interface through the IO-Uring pass-through command. The first one is add dev, and is the command that is used to set up the device, to allocate the device and set up the most of the parameters with the daemon point of view, so the number of queues, the queue size feature. When this command is successfully completed, the uBlock.C0, this one, is created, and it will be used later for the data path. Another command used for the uBlock control character device is the setparams. This command is essentially used to set up the parameters of the standard Linux block device, like number of sectors, the block size, and other attributes. So when the application configured all the things, and it's ready to start to process the request, call the start dev command. And after this command, the uBlock B0, the regular Linux block device, is created. Of course, we have other commands, but we don't have time to cover. The last thing the application needs to do before starting to process the new request is to map the shared memory with the uBlock.C, on the uBlock.C character device. This shared memory contains one structure for each queue element, and that are identified by a queue index and a tag. This is the tag coming from the block layer, from the multi-queue block layer, Linux block layer. And we use essentially the tag as an index into the queue. And this shared memory is essentially used by the kernel to write all the information for the request that then the user space daemon needs to handle. So at this point, the daemon is able to start to serve the request coming from the block layer, from the block device. So what usually the ublock daemon should do is to fetch and commit requests coming from the device using the IOUring command with the ublock-C, in this picture, the ublock-C0 character device. So the SQE in this case are submitted by the daemon to notify the kernel, for example, to notify that a request is completed. And the CQE is used by the kernel to notify the user space daemon that there is a new request to do. And as we saw, to link the submission queue with the completion queue entry, we have the user data. And this is opaque value for IOUring, but also for the ublock driver. So it's only used by the application, by the daemon, to link as an SQE with a CQE. Now, let's take a closer look of the IOUring command used on the ublock-C0 interface. The first one that should be used is the fetch request command. This command is issued only once per each queue element at the beginning of the application, and essentially it is used by the daemon to tell to the kernel, hey, I'm ready to process a new request for this slot. And a slot is identified by the QID and tag. And the application must also provide a pointer to the user space buffer that will be used to handle that request. In this way, the kernel can map, for example, put the data there. At this point, the application fill tell to the kernel that is ready for all the slots, almost. And when the kernel receives a new request coming from the Linux block device, it generates a new CQE and put into the completion queue to notify the application, hey, we have a new request to do. At this point, we need a new command that the application needs to use to tell to the kernel, hey, I completed the request. And it is this command, commit and fetch request. Essentially, it's kind of optimization. So it's a single command that allow the application to tell to the kernel, we completed the request, and now we are able to handle a new request for that slot. So it's much similar to the previous one. The only difference is now the result field is valid, contains a valid value that is the result of the application request completed. The rest is pretty much the same of the previous command. So the CQE are always used by the kernel to notify the application we need to do another request. This was the overview of the kernel stuff of IOUring and ublock, and now let Herman talk about the user space.
No. I think I broke it. Okay, sorry. Well, how we can use that? Currently, this is very experimental. So not only the kernel API is changing a lot, but also the user space API is changing a lot. So one of the options that you have is to use the UBD server from Ming. It's also a very fast-moving target, so there is a lot of development inside. And currently, it's just developer to be used as a server directly, providing some of block device that include that. For example, QCode2, that is one of the motivations to develop this ublock. There is many previous attempts to put QCode2 inside of the Linux kernel. So, but it's a, let's say, quite complicated format and like a big target. So that's the idea. Inside of the UBD server, there is the library, the lib ublk server, but still is also very experimental. So the API is changing a lot, but there is plan to, in the near future, to take that library to outside and be a proper library to be used directly instead of trying to use that. SPDK also supports ublk, but they have their own internal library. Basically, currently is one of the maybe easiest option is to write your own library to interface directly with the kernel if you need to implement it, and they do that. Also, there is a Rust version developed by this fine gentleman. Yeah, it's German. I have a whole country for me. Sorry, I lost the thread. But currently, since the kernel, especially the kernel, is like a moving target, we are waiting until at least the kernel API stabilize a little bit. And also, I think Ming is interested to continue the work in that. The idea of that crate is also to provide, of course, a Rust API that is safe and difficult to misuse, and maybe small and very simple C bindings. So the idea is to be double use, basically. Another option is developed by Richard Jones, one of our colleagues, is NVD ublk. He wrote, it take the client, the NVD client from the kernel to user space using ublock. So it's quite nice also as an example to how to use this library. He is using the library, the Ming's library currently. So this is another very interesting project for Richard, that is ublk loader, that is part of NVDKit. NVDKit is an NVD server, client, I always mix it, server, with a plugin interface. So the idea is you have a plugin file, so you can say, okay, this file, I expose this file as a NVD device, or just memory, etc., or a file over SSH. So the idea is to reuse all that framework, that infrastructure of plugins, using ublk. So if someone wants to experiment to ublk, I think this project is the easiest one to start, also because you can write your plugin in Python, for example. So I would sincerely recommend this project if someone wants to do some experiment with ublk. This is the easiest path currently. As I said before, QCode2 was one of the main motivations behind ublk. Currently, the ublk QCode2 that is implemented by Ming is basic, it's not fully complete. As I say, it's not an easy format. They have a lot of features. So the idea is QCode2 has a really nice set of features, and we want to provide those features outside of a virtual machine. For example, especially for containers usage, or to a better loopback device, for example, with all the features that we have for QCode2. And given that, thinking, okay, we want QCode2 with all the feature set, but all the external implementations of QCode2 are always simple, like write and read, and pretty much that's it. Why we don't use the QEMU block layer, the QEMU storage daemon, that is already have a lot of features, the full feature of QCode2, and we just export that implementation using ublock. So that is the project with Stefano and with the intern from Aurici, we was doing the last few months, to be able to export all the block layer, the QEMU block layer, using ublock. The QSD currently supports NVD as an export, Fuse. Those two are not designed to be fast for performance. And the vhost user block, that user is restricted to VMs. And the views, that is a similar idea like ublock. I mean, not the same implementation, but the same idea to have block device in user space. This is the project that I talked before, is to extend the QEMU storage daemon, export all the block layer using ublock. We have a proof of concept. Still, the development we are working on it, so it's someone want to find like a very interesting project to collaborate, this is one of those. And also the Rust crate. The guy that makes the Rust crate is good guy. And also one of the motivations of the Rust crate, by the way, is to export the new RSD. Also to have this capability to export the block layer of the new block layer of QEMU using uBlock. The main motivation behind the Rust storage daemon is a bit complicated. Has to be with an ongoing development to have multi-queue in the QSD, and recently was released version 0.1. So there is a couple of blog posts that are really interesting to read. So also recommend to take a look. And it's also very interesting project if someone wants to dive into Rust, and especially async Rust. So this is the next thing that we want to work. And basically, it's all I got. So thank you. The question is if we compare the performance of the uBlock and user space with other currently options. For example, MVD. Not yet. We have some fake numbers, but not proper benchmark. We expect that, for example, with NVD, Fuse will be faster because we don't need to use the whole network stack, for example. Of course, NVD also can be used in a Unix socket. But also, those were not designed for performance. And also, we still think we can tune I/O urine more, because the thing with I/O urine, all the I/O urine-based stuff is, if you want performance, you cannot just throw I/O urine to the problem and try to make it faster. So you need to design it from scratch to support that. So the idea is to complete the uBlock export and then the proper benchmarking, especially with VDUs. That is probably the main competition.
So this is all actually really cool things, and as someone who works on developing image build tools, one of the really annoying, difficult problems is that doing sophisticated image building unprivileged is functionally impossible because of having to interact with loop devices. Is there a path for being able to use this to be able to make provisioning and deprovisioning loops available without having to have the rest of the application run as root?
The question is if we can use this unprivileged without root, basically. No. Currently, yes. It's a recent development. We didn't talk about that because it's, well, unprivileged user support was a feature recently added. So yes, it's still in development.
Yeah, still I saw some patches in the mailing list, but not yet merged. But anyway, uBlock will gain the possibility to use unprivileged users.
Yeah, it's in the user space it's already done, but the kernel part is missing. But of course, you can compile those patches and have the. But yeah, that's in the near future. The original motivation also was to provide this for containers.
Yes, excellent. The question is, we submit request and complete, and RIP completion with IOUring commands. So if we have request in flight, we take new request only when we issue a new IOUring command. Is that the question?
Yeah, I'm just wondering, like implications on latency, because you're waiting until you actually look at the new request.
You issue a new command to fetch the other request to do, but yeah, in the meantime, you can still serve the other request, and you don't need to complete all of them.
Right, but you only look at the new ones once you have completed one on one. So the new one has to wait until that time.
Okay, but you can also, if you don't want to complete that one, you can also ask for a new request. Also, if you don't, you didn't complete that one.
Using the command that you said you would use initially, like the fetch.
No, the commit and the fetch request is per single tag per queue. So if you have, for example, 100 elements into the queue, you are using only the first 10%, you can still ask for the rest. So you don't need to complete the first 10.
Right.
So in this way you can do, you can fetch new element also if you are not completed the previous one. So for each element that is for each tag you need to complete, and of course, because the tag is the one generated by the Linux block layer multi-queue, so if there is the request in flight cannot be used for another request.
Okay, thanks.
Yeah, when you mean container, where does it impact when you use uBlock? Will get the device in the right namespace for the container?
The question is, when we use a uBlock, the device, you mean the Linux block device, will be in write mode?
Yeah, in the namespace that is like, so the example is that right now when you create loop device, they are created outside of the container.
I don't know this detail. I don't know if you...
No, currently the device is not namespace. So there's, yeah, basically the security goes differently. Basically, especially in the unprivileged part, is only the family, the three family of the process that created the device can access that device. But it's not namespace. Unless, that is my knowledge so today. I don't know if that changes because Ming is pretty fast to do stuff, so probably this morning is namespace or so, I don't know.
Yeah, this is very related to the question here that for all image building tools, having a way to get a device like this, like a loop device like this, inside a namespace, inside a loop namespace, would be useful.
Okay, well, but this is outside the namespace, but you can restrict for the process that are inside the namespaces. But yeah, I get it. The namespace is preferable. Yeah. So, an idea that we can work on that.
All right. Unfortunately, we're out of time. So I'm sure that if you have any more questions, you can ask personally. Okay. Thank you again. Sorry for the short delay. And we have Eric with us, and we're talking about Asahi. You can start.
Thanks very much. So I gave a similar version of this talk at FOSDEM. Pretty much the same talk. This is just an updated version. It's just a general update of what we do in the Asahi SIG in Fedora. And when I arrived in Brussels that time and I went to do the presentation, when I connected HDMI to my Mac Mini and it didn't work, but there's a part of the Apple Silicon, it's called DCP or Display Coprocessor. It's specific to Apple hardware. And we found a couple of bugs and they got fixed and it's much more reliable now. And I haven't seen an issue since until today. so whenever I present, I hit a DCP bug, but that's the way it goes, you know. So this is an update on Fedora Asahi Remix. So it's simply Fedora for Apple Silicon. So yeah, I'm Eric Curtin. I'm a software engineer at Red Hat. I work on automotive stuff mostly. So why do we care about all this stuff? So Apple, you guys probably know, but Apple released new ARM-based Apple Silicon device late 2020. As of this month, the entire Mac lineup uses Apple Silicon chips. And why do we care? There's actually a shortage of well-upstreamed ARM devices. So this is one of them that's in the process of getting upstreamed, and even the code that isn't upstreamed yet, it's all publicly available, and the upstream guys are doing their best to keep pushing as much as they can upstream. Another cool thing about these devices is the firmware is unlocked out of the box to run third-party operating systems. So I'm talking about Linux, obviously, but there's some guys run OpenBSD on Apple Silicon. This is actually a feature of the device. It's not an exploit or anything like that. One thing I find useful is the firmware. It's even unlocked down to the EL2 layer, so which means you have KVM support and all those goodies included. So they're really, really fast, and they're great bang for buck. You can get some of these devices now for I think like €700 dollars, and they're pretty fast. Why do I care specifically? I work with, I said this already, with Red Hat Automotive, and many of the automotive boards are ARM-based. So I end up doing quite a bit of work that requires me to have some kind of ARM environment. So the Apple Silicon devices allow me to iterate really quickly and build and test my code much more quickly than I would be able to on other devices. And I learned more stuff about modern ARM hardware and software implementations, kernel space, Rust, etc., just from kind of following the effort and getting involved. Yes, so this will give you an idea of the performance. When I first purchased this machine, I was using a Raspberry Pi. So this is the number of seconds it takes to build a project I was working with at the time called libcamera, which is a C++ code base. And I was doing my development on a Raspberry Pi sometimes, which is the top line. So that's how long it was taking to build libcamera. I also created this kind of Fedora container environment on my Android phone. It worked. So that's the green and the yellow bars. And the red bar is my company issued laptop. That's just an Intel laptop. And funnily enough, this Apple Silicon device was even cheaper than my company issued laptop, but it's faster. I took those benchmarks like well over a year ago. I think at the time it might have been even a Linux VM running on top of Mac OS, but yeah, that just gives you an idea of the outstanding performance. So what makes Fedora Asahi great? We have absolutely amazing upstream folk. I don't know if you follow a few of them on Mastodon or Twitter or whatever, but they're really amazing. I can't say how amazing they are. And I'm not going to go through the list of names because I have fear of mispronouncing someone's name, but they're all there. We also have great downstream folk. So Neil and Davide are in the crowd there. There's Neil. Davide is here. Davide is over there. So they're part of the SIG, and they're here obviously. So if you ever get an opportunity to grab 5 minutes of their time to pick their brain, I'd always recommend it. They're outstanding Fedora and CentOS Stream contributors. And we also have Michelle and Leaf Liddy and many more. So one of the things I really like about this SIG and this community is everyone kind of has this upstream everything attitude, if at all possible. So that's one thing that's in the spirit of various kind of ARM-related certification, like works with Chromebook or System Ready, or there's a RHEL certification as well. And well upstreamed ARM devices aren't as common as they could be in the ARM ecosystem, so I really like to see that this community kind of has that attitude. So this is our general workflow. We push as much upstream as much as we possibly can, and then we try and propagate it to Fedora, and that also ends up in Fedora Asahi Remix, which has some forked packages just to make things work. But this isn't the only workflow we use. Like sometimes we have there's publicly available code. It's not ready to go upstream. So we maintain copers and that kind of thing for that code that's not quite ready for upstream yet. Yeah, this is kind of another thing. In the best case scenario, basically this Fedora Asahi thing doesn't really exist anymore. You can just install standard Fedora out of the box pretty much on an Apple Silicon device, so obsolescence would actually be a success. These are just some forked packages we have in Cooper at the minute. There's not as many as you would think. There's U-boot, kernel Edge, a slightly different version of Mesa, and a handful of others. And some of those will become obsolete in time also. Yes, there's actually 3 types of kind of Fedora kernels that boot on Apple Silicon devices at the moment. So the actual Fedora kernel, like kernel arc, that has Apple Silicon's partial Apple Silicon support merged, so it boots, but it's kind of more a boot to shell experience at the moment. Like, don't expect accelerated graphics and everything to work. So yeah, we test and enable configs as support arise upstream. This is built with 4K page size, which is kind of the most common page size across various CPU architectures. So not everything is upstreamed with support for 4K page size, at least not yet anyway. And the Apple Silicon hardware, say Mac OS, runs with 16K page size. So the hardware is actually designed for 16K page size. So if you run the standard Fedora kernel, you take a small performance hit there. But there are advantages to that because you have increased compatibility when you use a 4K page kernel. So there's trade-offs there. This is one of the kernels we maintain. It's the Fedora Asahi kernel. So this uses all the stuff from the last kernel we were talking about, and it merges in another kernel from the upstream guys that adds extra yet to be upstream packages. So we enable even more configs, and we build it with 16K page size instead, which gives us increased hardware support on the devices. And this uses software rendered graphics. So it uses simple DRM, if any of you guys are familiar with what that is. And now, we have another kernel. Our kernels are based on the branches the upstream Asahi guys create. So one of those kernels is called kernel edge. I just said I'd describe edge in this context because edge is so fashionable the last few years as a term in general. But edge in this context, all it means is it's a kernel with additional experimental features. So this uses the last kernel as base and adds a couple of more patches and more configs. So the only difference at present is this one also has accelerated graphics. So as a user, that's the only difference. But under the hood, there's a couple of more differences. Like, this is pretty much the only Fedora kernel it's the only Fedora kernel out there I'm aware of that's built for Linux support. So this is to enable the kernel space side of the GPU driver. And actually, this is going to be promoted to the main Fedora Asahi kernel in the coming weeks or month. So the difference between the two kernels might change. We'll have a discussion about that with upstream and in the SIG and whatever. So we also had Clang LLVM as build dependencies as required by the Rust toolchain, because you need those build tools to build Rust code. At least at the moment, that's the only compiler that can do it. And we have a forked Mesa package. But even that forked Mesa package, all that code is being actively upstreamed, so that fork may well, that could be one of the next packages to disappear without giving any timelines. So this is just an example that in the recent kernel release, 6.3, I think was released about, I don't know, 2 months ago, 6 weeks ago, around that time. So there's many examples of Asahi helping the community as a whole. I thought this was a pretty cool one because up until 6.3, on any big little device, so a device with different types of cores, you had to pin VMs to a specific set of cores, so you couldn't mix match, say, performance cores and efficiency cores. But this really talented virtualization guy, he made it possible so you could use all the cores in a guest VM on a big little machine. And he used Asahi Linux to do all the work. So I thought that was pretty cool because that didn't benefit Asahi, it benefited loads of ARM SoCs, and even there's an x86 Intel chip that has big little cores as well. Yeah. Is it Alder Lake or? Is it Alder Lake?
Yeah, Alder Lake, that's 12th generation of the E&E cores.
Yeah, yeah.
That's essentially this architecture, although different.
Yeah, yeah. So it even fixed that issue on non-ARM architectures as well. So I thought that was pretty cool because they did all that work on Asahi. I pretty much gave this talk at FOSDEM. So this is just pointing out some of the differences. There's loads of differences, so I just summarized a couple. There's been some DCP fixes for HDMI. Accelerated graphics have come a long way. They're really mature in performance. I don't know if you watched the streams. I'm going to talk about them in the next few slides, but some of the graphics work that has been going on is pretty amazing, and they have some really demanding games and that running on Apple Silicon now. We have Fedora branding. There's been because most people are running 16K kernels on Asahi Linux, there's been page size fixes and all sorts of user space applications. This is just a couple I listed off the top of my head. So initial support for DM2 SoC, and many more things. This is a slide I added this morning because I was toying around with the idea of showing off the accelerated graphics. But in the interest of time, I don't want to do that. And Asahi Lena, that stream on YouTube, she has so many examples of that. So if you're interested, feel free to check out that stream. Hector Martin does streams. Neil Gomplet does some streams of downstream work. And yeah, they can be pretty interesting. This is a question we get all the time. Can I use Fedora Asahi as my daily driver? And you may. It depends on what you use it for. I've been using it for over a year now, every day for my work. But it really depends on what you want to use it for. So to get an idea of feature complete lists on the upstream Asahi wiki, that's a good reference point because it tells you what works and what doesn't. Like 2 examples of things that don't work are sound and camera, although there's progress being made there, especially in sound. But like there are workarounds for these things, like Bluetooth works perfectly, pretty much. You could use a USB camera, etc. So I asked a couple of days ago, should I share this link? And nobody complained, and 1 or 2 people said, yeah, sure. So we still deem this unreleased, but this is the link to the installer if you want to try it. It's up to you. It works pretty well, but don't expect things to be perfect. Forks. So back when the Asahi guys initially released, there was loads of different Asahi forks forming. So one of these is the Leaf Liddy fork of Fedora, and he's actually a part of the SIG these days. So he has this fork also of Fedora, which it's still maintained to this day. It's consumes the same pancakes. No, what that's supposed to say is that it's 99% the same as this one. It consumes the same packages, not pancakes. So it has a more minimal variant of Fedora Asahi, and it uses an OS composing tool called MKOSI, whereas the SIG images use Kiwi. Another interesting tool Leaf has on GitHub, actually, is because Asahi chain loads eventually to a U-boot UEFI environment, you can boot over USB if you interrupt U-boot at that point. And he has a cool little project, actually, that allows you to create flashable USBs pretty easy. So I think that project's pretty nifty. That should not say kernel edge. That's just some various links. And that's it. Any questions and answers, or any questions?
I have to ask, what is the difference between this Fedora kernel and the official Asahi kernel?
So the question is for YouTube, for the YouTubers. What is the difference between the normal Fedora kernel and the Fedora Asahi kernel? So,
I mean the difference between Fedora Asahi kernel and the official Asahi kernel.
Oh, yeah. The official Asahi kernel is more designed to run on Arch. So this kernel is based on the real Fedora kernel. The kernel you're referring to is designed for Arch, and the kernel config options are just completely different. But they are very similar.
The easier way to answer this is I'm going to refer to this as the Arch Asahi kernel.
Yeah.
It's one that Hector just built the K config from scratch and turned on things one by one until things started working.
Yeah.
I started from the Fedora K config and then added the stuff that's needed for Apple Silicon hardware enablement. So
Yeah.
we use the same patch set on top of an upstream tree. I take his patch set, apply it on top of the Fedora kernel. He puts his things on top of the mainline Torvalds tree and then builds it. So that's the difference.
Yeah. Why I prefer the Fedora kernel is because I know everything that works on this laptop is going to work. I know if I run Podman, for example, that all the kernel configs required for Podman are turned on. But if I use Hector's kernel, that mightn't necessarily be the case, because he just turns on the minimal, well, whatever is required for him, whereas this Fedora kernel has everything enabled on the standard Fedora kernel plus the Asahi stuff on top. So yeah. Yeah.
So now the question: does Fedora kernel less stable than original Asahi kernel? Because lots of features.
The question is the Fedora kernel less stable than the Fedora Asahi kernel?
No, not Asahi kernel, original Asahi kernel versus Fedora Asahi kernel stability. You said that original kernel has less features, one by one, enabled just to run. Fedora kernel has everything Fedora has plus Asahi patches.
Yeah.
So is it less stable? No.
The question is the Fedora kernel nowadays less stable? The question is the Fedora kernel less stable than the Fedora Asahi kernel?
No. The other way around. Is the kernel used in Fedora Asahi Linux is less stable than the original Asahi Linux?
Oh, the question is the Asahi kernel, the Arch kernel, as stable as the Fedora Asahi kernel?
Yes.
And yes, they're on par. Because what like Neil will do or I will do, we just merged the two kernels basically, so you have the best of both worlds. So yeah, they're on par. So anything you see, most of the things you see Hector do on his streams, you can do it on Fedora also. So yeah. Question.
We have a question from Matrix. How hard is to compile kernel edge in respect to of the Rust drivers being included?
I can see Neil like, oh my God, it's so much pain.
It takes me weeks every time to go to a new kernel.
Yeah,
Please repeat the question as well.
Yeah.
Okay, so the question is, how hard is it to build a Linux kernel with Rust support enabled? It's getting better. It used to be more difficult. I even have a contribution that made it slightly easier. It's pretty easy if you just install Clang LLVM tools and it works. But we do have an issue at the moment as regards versioning. You have to have a specific version of the Rust compiler for it to build without errors. And an issue we're starting to see kind of regularly is Fedora Rawhide, or not even Rawhide, just will bump their version of Rust C, and the kernel guys haven't arrived there yet. So we'll start to see build failures. So that's an issue for us. We're talking about long-term solutions to that problem. Davide has something ready. Well.
The idea is to just keep a package in Hopper that will be a part of the main compiler that spins to a previous version. So while we still have to deal with unstable features in Rust, which we unfortunately will have to for a while, we can still keep building the kernel and we don't need to maintain our own entire Rust stack, which is the Fedora one with minor changes. But we don't have to. This should give us a reasonably maintainable solution long term. These would probably take a few weeks to get to a usable state.
Yeah, I think what we're going to wind up doing is that Edge is going to test against the Rust compiler that's in Fedora, always the latest, and so if it will always keep failing, we will at least know.
Yep.
And then the regular one will just start building against the one that we blocked on.
So for the YouTubers, just to summarize the conversation in the room, we haven't fully decided on a long-term solution, but what we're thinking of is we're thinking of building kind of a kernel Rust package that basically pins the Rust compiler to a certain version just for building the kernel. But we haven't fully teased that out yet, so yeah, but it's in progress. Are there any other questions on the matrix? Okay. If there are no other questions, I guess that's it. Okay, thanks very much, guys.
welcome back. I hope you had a lovely lunch. Now, before we start, I would like to mention a couple of things. Don't forget that there's a party tonight, so if you don't have your PIN, pick it up at the reception. Also, we have a matrix room. If you want to ask questions and you're uncomfortable asking them out loud, you can ask there. And also, don't forget that tomorrow, don't miss the last session because there's always a quiz by Radek Vokal and some prizes at the end. And that's it. So let's go to Hangbin Liu from Red Hat, and we'll be talking about Linux tunnels.
Okay. Hello, everyone. Oh. Oops.
We need to call someone from IT.
Okay, let me unplug it. Unplugging it. Okay, good, works. Okay, hello everyone. I'm Hangbin Liu from Red Hat Network Service team, and today I will give us an introduction about the Linux tunnels. Okay, here's the agenda. First, we will talk about what's tunnel, and then what tunnels usually used in Linux, and then last we will talk about what tunnels could be chosen for cloud network. Okay, here's what's the tunnel in the real world. It's an underground passageway, and vehicles could go through it from one end to another end. And here's what a tunnel looks like in the network. A Linux tunnel is, in the concept, is it could encapsulate a network packet within another protocol and transmit them over a network. It allows you to create a virtual network link between the two endpoints and provide security and private communication over the existing network. So let's see what a packet looks like in the network. First, you see is the sorry. Okay. Let's wait. Okay. Here is what a packet looks like on the internet. First is the Ethernet part, and then is IP header. It may be IPv4 or IPv6 in the recent years. And the next is the TCP or UDP header. And the last is the payload or the data it carries. So what if this is internal package and you want to transmit from one internal network to another internal network through the public IPv4 network. Here is what we do for IP tunnel. Here is the internal package you have in the private network, and we put the existing or the outer header over the internal network header, and then the outer Ethernet. So this is what an IP tunnel looks like. As the name said, it's an IP over IP tunnel. So this is simple, and as the name said, it's IP over IP tunnel. So it's used to connect the two internal internal IPv4 subnet through the public IPv4 internet. The overhead is very simple, so it could only transmit the unicast packets. Okay, this is very old protocol. It was developed at 1990s. So excuse me. Excuse me. what's on? Okay, looks the connection is not stable. Yeah, unplug it and plug in again. Okay, let me go through it quickly. It was developed at 1990s. So after some years, there we have IPv6. It started used in the internet network. But how to connect the IPv6 networks between the public IPv4 network? We have the SIT tunnel. This was developed at year of 2005, and its name is stands for Simple Internet Transition. The main purpose of this tunnel is to communicate the isolated IPv6 network between the global IPv4 network. But after years of development, we also support IPv4 headers. So in functional, the SIT tunnel has already covered the IP tunnel, the functions. Okay. So, but after recent years, the IPv6 network also development, and we have a lot of global IPv6 networks. So here's the IPv6 version of SIT tunnel. It's IPv6 tunnel, and the out header you can see is using IPv6 headers. So this is IPv4 version, and this is IPv6 version. So recently, all the tunnels we talked about, the data are plain in the network. If anyone capture the packets, they can know what's inside in the packet. So how to protect our data? Oh. So we have more breaks between each slide. So how to protect the data? There is IPsec. IPsec actually have transmission module and the tunnel module. Here we will only talk about the tunnel in this talk. The IPsec support two models. One is the Edge model, is also it will do data authentication. Another is ESP model. It will encapsulate the inner data. So here, the Edge model only do authentication for the inner data, and the ESP will do encapsulate the inner data. But it also support to combine them together. So you have both Edge header and the ESP header. Okay, so we can protect our data, but sometimes we need to connect our network from, we want to connect to our company or school or some private network, and then we need to do some user identification. How to do that? Here we have PPTP tunnel and L2TP tunnel. L2TP is a level 2 protocol, and PPTP is only point-to-point protocol. So both of them are based on PPP protocol. But L2TP is level 2, so it supports to create multi-tunnels between the two endpoints. But L2TP, L2TP it has basic crypto method compared to L2TP. L2TP only could combine with the IPsec we just talked. So PPTP is a little faster than L2TP because L2TP need to do much more encryption. But on the other hand, the PPTP is not security and easy to be cracked, so it's not recommended in the recent years. This protocol was developed at 1990s, it's very old, while the L2TP is developed at 2000 year. So it's much, it's a little newer. But as we talked about, PPTP is faster, but not security, and L2TP is security, but a little slower. So how to balance the performance and security? Okay, we have OpenVPN. OpenVPN is very famous. It's also created at 2001, and with its default is using UDP module. So it has a very good performance, and also it uses libSSL to encrypt the data. So it's also very, the security is also very good. So, but it's popular since 2000, so it's already have 20 years. And recently we have WireGuard tunnel. WireGuard tunnel is created at 2015, and it's also merged to Linux at 2019. So it's a modern tunnel. It has a very Okay. WireGuard is a very new, new and open source VPN protocol, and is much faster than the OpenVPN because it has a very simple design, and it also have a lower overhead. The overhead is not much. It's very simple, and also it uses a modern encryption protocol than compared with OpenVPN, which uses SSL, which is old. So WireGuard is more security and more fast. So all the current tunnels we talk about has a fixed header, and it also has they are limited to with fixed inner protocols like we have IP over IP or IP over IPv6. The users need to configure different tunnel with different inner protocol. So how is there a way to not care the inner protocols? We can use only one outer header, outer protocol. We have the GRE tunnel. GRE is called generic routing encapsulation. It's also a very old protocol. It's designed at 1994 and updated at year of 2000. As the name said, it's a generic tunnel, so the protocol is independent. Not sure if it's because my computer is issue. So the GRE tunnel is a protocol independent tunnel. So it supports IP as an inner header and PPP. Also, it supports Ethernet header. It also supports to transmit the multicast traffic. As we talked before, IP tunnel only supports unicast packets, and GRE is support multicast routing, multicast traffic. As also its name is generic routing protocol, so it supports routing protocols like OSPF, but this not support on Linux. Some routers, like Cisco routers, they support this with OSPF. In Linux, we have GRE tunnel and IPv6 GRE tunnel, which is IPv4 and IPv6 version. And there's also a GRE type tunnel. The difference is we have an inner Ethernet header, so it could carry level 2 packets through the internet. And here also IPv6 GRE type tunnel. And Last is a ERSPN tunnel. It's called Encapsulate Remote Switch Port Analyzer. In the switch, in the hardware switch, there's a function that it could monitor one port traffic to another port through level 2, as is in the same switch. But sometimes we want to monitor all the traffic to another subnet. So with this protocol, we can. Thank you. With this protocol, we can monitor the port traffic through the routable internet and transmit to other internet, so other subnet. Okay. So the good part is we can extend the basic port monitoring capacity from layer 2 to layer 3. So the tunnels, we can see the tunnels can happen at multi levels. Here we have GRE over IP header or IP or SIT. Most of are based on the IP header. But also in the recent years, more and more tunnels are happen at the UDP level. Here we have 3 UDP tunnels. First, the full tunnel is full over UDP. It's developed at 2014, so it's a new protocol. The advantage of using UDP tunnel is UDP works over. We can use the UDP works with the existing hardware infrastructure, like the RSS init, the receive side scaling, and the EMCP over switch, the East Coast multipath routing protocol, and others like checksum offload and JSO GL. With this feature, this makes UDP tunnel has a significant performance increase compared with the IP tunnel. So that's why we talked about the OpenVPN and the WireGuard. They both over the UDP, so the performance is very good. The next is the bare UDP tunnel. Bare UDP tunnel is okay, the full tunnel is support IP and the GRE header as the inner header, and the bare UDP supports IP and the MPLS as header as the inner header. And the last is the GOE tunnel. The difference compared with these two others is the GOE tunnel has a GOE header. GOE is a generic UDP encapsulation tunnel. So since it's a header, but the header is also lightweight, so the speed is also good. But it allows the header have the optional data field and could be used for virtualization, security, and congestion controls. Okay, the next is the VXLAN. VXLAN is also developed at the year of 2014. So in the year of like 2000 or 10 years ago or 20 years ago, most of the data center are in the same place, or we separate the network with VLAN, and it's enough in that time. But after years of we have cloud network, the data center may may separate in a lot of places. So how could we connect this data center? So VxLAN is called a virtual extendable LAN. It was developed to address the limitation of the traditional VLANs. And the traditional VLAN, it has only 4,000 VLAN IDs, which is not enough for the large-scale data center. And VxLAN, it has 24 bytes VxLAN network identifier. It's called VNI. It allows up to 16 million virtual networks, which is very more than enough. And also VxLAN encapsulates on layer 2 Ethernet frames. So it could carry the layer 2 data over the UDP header. This means you can create an isolated network on layer 2 across the data center and the cloud network. This flexibility also allows VMs to be deployed at across the data center or cloud network. And you can migrate it from different physical place or data center and still keep the same logical network. Yes, and there are also some other protocols like the VxLAN, like the NVGRE. NVGRE is also has NVGRE is use a GRE header to encapsulate the data compared with the UDP header, and also like STT is use a stateless TCP to encapsulate data. They are different protocols, but they have similar similar functions to how the like the identifier to address the problem, to address the VLAN issues. Okay. But as we see, there are VxLAN is popular, but also how the NVGRE or STT, they all have fixed header, and it's not easy to extend. So what if we want to have some other features in the future? It's not easy to do that. So we have the Geneva tunnel. Geneva is a generic network virtualization, and from this picture it looks like the same, but actually Geneva header is a flexible header. It could have support to have using a type length value option, the TLV option. So this could make us to add new functions without modify the basic protocol. It's also use larger VNI field compared with VxLAN. Geneva use 22 bytes, and VxLAN only have Geneva has 32, and the VxLAN only have 24. So this is more than enough now. It also supports built-in support. The Geneva also supports built-in encryption to make the data more security. So also the VxLAN encapsulates layer 2, while the Geneva could encapsulate layer 2 or layer 3, so it's more flexible. So many sources could become the new future tunnels we can use on. The ON, and the ON is currently still using the Geneva tunnel as the default tunnel. So that's almost what we talk about on what do we know Linux support now. let's think. Since the cloud network is more popular, so let's think about what kind of tunnels should be used in the cloud network. First, I think the cloud network may have different protocols. So GI tunnel should be fit because it could support different inner protocols. And next, as we know, VXLAN. VXLAN is popular, and it has a large VI field to separate the networks. And last is the generic tunnel. It's the future. It is designed for the future. So, okay, that's all the tunnels we know, and I want to introduce. Thank you. Any questions? Okay. Thank you. Thank you. Okay. Thank you.
Sorry about the cable.
Or maybe
Sometimes this video capture doesn't. Okay. Hello everyone. Welcome to another session, and we have Jakub Fischer with us, and we will talk about NixOS. Take it away.
So, once upon a time, okay, this seems to be working. Hello. As I've already been introduced, and the presentation is going to be about a very beautiful operating system called NixOS or NixOS. I don't know which pronunciation is correct, to be honest, so I'll be using both. First of all, this talk is going to be slightly different in terms of a few technological tests. If you open this link, you should be able to follow the slides on your device live. And there's also, if you look to the top left corner, there's a hamburger menu which you can open, and you should be able to pose questions. So if you have any questions, try to pose them through this live show. And I will do an extended QA actually, because I think, or I hope there will be more questions than I can answer in the talk alone. So feel free to put in there. And if you can put test question, maybe I'll see them right here and see if it works. Anyway, don't panic. NixOS really doesn't bite. This is a sort of a sales pitch for the OS, so I'm not going to go into many details. But I'm not a very good salesperson, so I'm going to give you the spoilers right in front. NixOS really doesn't bite. That's a lie, of course. It doesn't bite more than the others. If you do try new distros, you always get bitten by something. NixOS is no different in this, but that's the point of this presentation. It can be a bit frustrating because it's a bit different distribution than the others, but once you start using it, you'll learn to love it. I already see people with t-shirts already here, so there's living proof it does. It'll grow on you really, very easily. So, you might be asking yourself, why should I listen to this guy? Well, my name is Jakub. I've got all the socials, everything. But more importantly, I've been using Linux for over 20 years now, 19 of which I've been using Linux full time. I've been paid for using Linux for well over a decade, and most importantly, I've been using NixOS as my only desktop operating system for over 4 years, so I hope I've got a little something to say on the topic. So what is NixOS, and why should you care? Well, if we want to talk about NixOS, we first have to take a little detour and talk about Nix, the package manager. Nix, the package manager, is a very specific package manager. You already know what package manager is if you're using Linux these days. Nix does the same role, but it does it quite differently. It is functional, declarative, it's quite fancy, and it provides immutable results, which is probably the most interesting part of this piece of software. We'll talk about all of these points very soon in detail. One of the more interesting things about Nix as a package manager is that it actually runs on everything. It's not bound to NixOS, so you can try Nix on, yes, even on phones. So, NixOS, what makes it unique? Well, Nix. Nix gives NixOS many features, like immutable package management and dependencies, fully declarative system configuration. It's if you are experienced with, say, things like Terraform or Puppet, you might know what this means. If you're not, follow my lead, and you'll know what it means very soon. The system state is atomic. It means that, well, it's atomic. You know what it means, right? If you have a database, atomicity is the inherent feature of NixOS configuration. It protects you. You really can't break NixOS easily, because if you do a typo or something, the system just won't build and nothing will happen. Hence the atomicity here. And all the configuration for the operating system is in one place, and it's written in a single language that's, well, rather easy to understand. NixOS is also a quite user-centric distribution, because it allows you, as a user, to create dynamic environments for your applications, environments plural. You can have multiple environments in parallel running for different workloads, different experiments, anything you want. It allows you to build different and completely independent user profiles, and independent, what it means. Again, we'll talk about it very soon. User configuration can be done in a very similar way than the system configuration is done. That is being declarative and, well, atomic and everything. And of course the community. The NixOS community is one of the greatest community out there. People in NixOS are aware that the distro is different, and they are very, very helpful to newcomers because they understand the frustration the newcomers come with sometimes. Don't be frustrated, really. It's not worth it. It's easy. So, let me give you a bunch of good reasons to switch to NixOS. It's personal opinions, no warranty or management better, and bunch is just a subjective term. So, would you care to guess what this is? No guesses? Yeah, it is. It is an NixOS configuration, but this specific configuration is actually complete and working system configuration. This is all you need, like literally all you need to have your desktop running full NixOS with Plasma 5, with Firefox, and your favorite editor. Like literally all. There's nothing, you don't need to add anything to have a working system. So this is how easy it is. Well, you probably see this. Okay, I'm lying just a little bit. This is a way to split your NixOS configuration if you want. But this specific case, this specifically is this. This is a configuration for file systems and such. This is generated for you by the installer, so you don't have to care about this. It just has to be there because there has to be some kind of initial state, but this you don't have to care about. This is not a complete example. I've got a much larger configuration in there, but you get the idea, right? So about the NixOS configuration. Well, as I said, it's declarative. As you have seen, declarative configuration means that you basically say what you want. But you don't have to say how it's done, because that's what Nix does for you. You just say, okay, I want Firefox, that's it. I want Plasma, I want X server, I want an Nginx container. You just say that you want something, and it'll magically happen. It is immutable. It means that once the configuration is made, it doesn't change. And if you make the configuration with the same inputs, you will always get the same outputs regardless of the current state. So the current state doesn't really matter when you create a new configuration. That means it's reproducible. You can always make the same configuration all over again. You can test it, and you can be sure that if you do the configuration same and you give it the same inputs, you will always have the same outputs. And it's also atomic. It means that once the configuration is, let's say, created or built in NixOS terms, then you can switch to it. And the switch is atomic. You know atomicity from databases, probably. It means that the switch either happens at all, either happens completely or doesn't happen at all. So it's virtually impossible to end up in a half-configured system because of this atomicity principle. It's not possible to break things just by rebooting system or something during the build or anything, because that's the inherent property of the system. So how do you deploy this kind of config? Well, there's a simple command. This command will take all your configuration and it will it will build you a new operating system configuration, and it will switch your runtime to it, just like this. You might be asking yourself right now, well, I want new packages. I always do some pacman or apt or yum or whatever, DNF, I heard is the new thing in Red Hat world. So how do you do that with packages? I mean, do I have to do this all the time if I want to just add new packages into the system? Well, you can, but you don't have to, because we've got these profiles I've been talking about a while ago. This command will install the package Krita for you in your user profile, and once it's done, you can just start it. But let's say we don't like Krita. Let's say, okay, yeah, I don't like this editor. What do I do now? Well, you can uninstall the package, of course, but then you say, okay, but let's try a different thing. Let's say I want to try Inkscape. Do I have to do the install and uninstall again? Well, again, you can, but you don't have to. Nix has this great feature of running actually a package or package output that you don't even have to install. This thing, if you run this in your Nix environment, it will start the Inkscape package for you, but it will not install it into your environment. This will create some kind of, let's say, one-off ephemeral dynamic environment just for Inkscape, which will disappear after Inkscape ends. Which is great for testing new stuff, which is great for if you don't want to take care of any configuration or anything, if you have your configuration completely declarative, which you can, of course, even the packages, that you want to try things, you can do it like this, and you don't mess up your profile if you don't want to. So, testing packages is great, but can I test the configuration of the system as well? Well, of course you can. Because the Nixos rebuild command doesn't only do switches, it does a bunch of other things. Let's talk about the dry activate thing. That's one of the more interesting things. The dry activate does something like Nixos rebuild switch, except it won't do the actual switch. It will do all the builds, it will show you what will have to be done in order to switch to the new configuration, but it won't do the switch itself. That's good for testing things if you have some kind of inconsistent configuration that requires runtime operation. Like what happens basically, this is the thing that happens at switch is something like what happens in post hooks on package installers, like unit reloads, runtime configuration, these kind of things. So NixOS will tell you that this will happen if you want to do the switch, but it won't do the switch. Another interesting thing is the Nixos rebuild boot. This will build the configuration. It will prepare your bootloader, so if you reboot your box, it will boot into this new configuration, but it won't touch your current config. This is useful if you have, let's say, a kernel upgrade, and you're not sure that your current packages will work with the newer kernel for whatever reason. So, there's one more interesting thing, and that is build VM. You can actually build your whole configuration into a totally separate virtual machine which you can play with. I don't know that if any other system does this. So now you've tested everything, and you want to try to break it, right? Well, this happens with common distros. You edit something here, you add a package there, and everything breaks, right? You've been there all. Well, not with Nixos. Good luck breaking that. Because, again, in order to break things, you would first have to switch to the configuration, but you won't switch on syntax error because the build will fail. You won't switch if you have compatible settings because the build will fail. It won't even build if there are upstream bugs NixOS knows of. That happens a lot of time to me when I try to build a newer kernel with ZFS, because I use ZFS, and ZFS doesn't always keep out the newer kernels. So if there is a new kernel coming in which is not yet compatible with ZFS, I got a message, hey, your package ZFS is broken, you can't do this, and I won't break my system. On Arch Linux, for instance, when that happened, and I missed the little message in Pacman that something didn't happen correctly, but it still built the kernel, I rebooted, and the system didn't boot, of course, because there was no drivers for ZFS. This does not happen on Nixos. But what happens if you do manage to break the thing? I mean, it's pretty hard, but it is also possible. So let's say we broke the system. Do you know what this is? Okay, for those of you who don't, I'm sure you know what this is, right? Yeah, it's true. Nixos has its own time machine. You really can do all these things because NixOS has all these properties. Again, these naturally lead to the time machine capabilities, but since NixOS is made by humans and it's not 100% foolproof, nothing is, you always have the option to do a rollback. I mean, if this switch happens not to your liking, you can just do this single command and your Nixos will roll back to your previous configuration. Well, what if the switch breaks the system? As I said before, NixOS configuration, we call them generations, are stored in your bootloader. So even if after the switch your system becomes unresponsive for whatever reason, you can always reboot it and pick whichever generation you like. Usually the second to last because that's the one that probably worked. But if you do a lot of upgrades, it might be a different generation. What happens to these generations if you don't need them? Well, there is something called garbage collection, which you can trigger manually, and it works pretty much like your standard programming garbage collector. You've got profiles, you've got things that configuration links to, and things that no configuration links to, and those are removed by the garbage collector. So, these are, I think, the most interesting things about NixOS itself, but let's talk about the Nix package manager as well. I already told you something about the, I already spoke about it, the independency. As I said, Nix allows you to manage your own profile, your own packages, your own pretty much everything independently of the system admin, as long as you stay in your user space, of course. Users are also independent from one another. That's quite well, implied, basically. But you are also independent on your distribution or even operating system. NixOS runs almost everywhere. I've been talking about profiles and environments. These terms, I would prefer not to define them. These are the terms I'm using mostly for you. These are not, well, sort of official, but I'm not aware that these are being used as official as I'd like. But whenever I was talking about a profile here, I was talking about the configuration of your user profile mostly, the same way as you configure the system. Like you have a Nix, let's say it's called Nix expression, some sort of, you build it, you've got your configuration, you've got your packages and everything defined in there, and that's static. And when you change the configuration, a new configuration is created in the profile, which creates a new generation of that profile or configuration. And you can go between them as much as you can with the OS itself. But there's also this concept of environments, and those environments are dynamic, ephemeral. You can make them on demand, like I did with the Inkscape example. You can do much more complex configurations than that. You can create a using this Nix shell capability, you can create your own environment for, let's say, package development. You can have multiple libraries with multiple versions of these different libraries having in different environments in parallel. So you can test your configuration against different libraries at the same time without having to touch the system or do anything fancy with like VNs or something like that. You can just create the environment on demand and you can destroy it after you're done. So that's I think, one of the great things for pro users, but it can be useful for beginners as well. And of course, Nix runs everywhere. Like literally everywhere where Linux kernel is, there can be Nix running on it. So you can run your Nix, you can run Nix on your Red Hat systems, you can run it on Ubuntu, so you can run it even on Macs. That's actually wildly supported by the community. Mac is the second largest, maybe even no, I'm not sure, but it's one of the 2 largest platforms Nix builds for. So even if you use macOS, you can use Nix on macOS without, without any hassle. And of course, it even runs on Android. I personally don't use that, but I've seen it working, and I've seen there is a good support for that. There are ports for other platforms. I think I've seen a discussion about FreeBSD. Not sure what the state is, but well, you may follow that if you're interested in that. Good, right? Well, sometimes NixOS doesn't really fit your need. And the most, the biggest example, for instance, with beginner users and normal users like us is unfortunately games. Specifically, and that is the sad part, Linux native games. Like Unity 3D games, I was unable to start 2 out of 3 Unity games on NixOS, no matter how hard I tried. Because, and that goes for native closed source applications as well. If you have any closed source application that you need to run, you might find it difficult to run on NixOS. It's not impossible, but it's definitely not going to be easy. Because something called the Nix store. This is how Nix creates everything. It creates packages, files, configuration, everything NixOS outputs ultimately lands in this directory, which is read-only for users, so you shouldn't touch it otherwise. And it contains, as you can see, it contains all kinds of random things. This thing, this is a cryptographic hash of the specific build of the thing that makes it unique, and that's what allows you to have multiple versions of the same libraries, because the prefix will always be different. But this prefix will always be the same if you put the same inputs to the same configuration. That's the immutability part. But since everything is easier, it means that nothing is in the common directories like userlib or even bin or sbin or user sbin. These directories are usually mostly empty because the, the execution environments for these packages are built per package. And that makes things that rely on those, that assume these sort of standard but not really standard locations to be present, and you have to fix those, and it's not easy. I don't want to go into technical details, but be prepared, and if you have any closed source thing, you might run into these issues. So, I hope you have questions. We can answer here, because I only went through like 3 or 4 things that might be interesting, and I'm sure there are much more use cases out there, because each user is unique and have unique needs, so go ahead.
So if I want to build a closed source application, do I have to somehow into the mechanism mix to be able to download all the packages that I have been installed?
Well, if you want to build a closed source, the question was, what do I do if I want to build a closed source application? Well, if you want to build it for NixOS, then you can build it just like any other application. The distribution in Nixstore is binary, so that's not a problem. But if you want to distribute it and for it to be compatible with NixOS, then my suggestion probably would be build it statically. Let it ship all the dependencies it has, like all the dependencies, like Go applications essentially. We can also talk about server use cases. Okay, go ahead. I'm sorry, can you speak a bit louder? No, that's the NixOS switch does. It switches your current runtime environment to the new generation, but you might have to reboot it if you rely on things that only happen at boot, like kernel upgrades. That's the same with any other. Sorry?
Repeat the question, please.
Okay, sorry. The question was, do I always have to reboot when I do the configuration change? No, you don't have, unless the change requires reboot by design.
Where does the package manager take the packages? Is it some kind of a distribution like?
Yeah. The question is, what is the source of the packages? Well, this is interesting. Source of the packages by default is something that is called Nix channel, which contains information about all the packages in source, and there is a build system that that caches the builds basically, and it stores them under these hashes. So there is an online caching system which has all these packages built with these hashes for the official channels. So you can always download. You can either build them yourself, or you can just try the cache if the package already exists in there, and is downloaded from there automatically if it exists. If it doesn't exist, it gets built.
So how do I know that, say, Little Linux there is built from the upstream with no other additional changes? How do I know that?
How do I know that this package is built the same way? Well, you can build it yourself, and you will see that this hash will be the same if the inputs are the same. That's the immutability part. If the inputs are the same, inputs being both the configuration and the sources, like a git commit for a specific commit from the sources, then if you build it from there, then you will end up with the same hash. If you don't, then there's a problem somewhere you need to solve, and it's probably a different source, or maybe it is a security issue. Maybe someone tried to touch your sources. So if you don't trust the caches, you can build everything yourself.
And the last question is, do I trust the sources then? Is it something that you would think that you can trust, or is it something that you'd recommend to always build our own packages?
I think are the sources trustworthy, essentially? Yes, I think they are. I mean, NixOS is a huge distribution. Everything is cryptographically signed by the package developers. You can always go through the public history of the packages on the Nix packages GitHub repo. And I don't want to lie here, but if I recall correctly, you should be able to know this hash before you even build it. This hash is calculated from the sources, not from the outcome. So, yeah, you should be able to check. No more questions? No server admins interested in NixOS? Okay, there was one.
How much space do you recommend for NixOS?
Well, how much space does it take? Most of the space, like the bulk of everything, is in Nixstore. Almost everything is like, if you have 50 gigs, then 49.5 gigs will be in Nixstore. It really depends on how many generations of history you want to keep. If you only work with the latest generation, then the space is pretty much the same as with any other distro. Like if you have many packages, let's say 10, 20 gigs, if you want to keep generations, multiply by the number of generations, essentially. There was a question over there, I think. Okay, go ahead. Well, can you have Nix store backed by external storage? Yes, you can. As long as it provides basic POSIX compatibility, then yes. And I don't think even POSIX compatibility is required. I'm not sure on that. But yeah, it can be. It actually even happens when you have, let's say, virtual machines on a vhost, then the vhost can share its own Nix store and share it to the machines, and they can share the packages because, again, the packages are addressable. Probably yes. If you mount an ISO image, yes. The question was, can I use an ISO image? Yes, you can. Someone, okay?
Is it possible to install packages from other distributions somehow? Because I imagine a lot of software will not be available specifically for Linux because it's niche OS.
Ha, that's that's a nice question. Is other packages from other distributions available? Well, let me answer slightly differently. Nix packages is the largest collection of packages of open source applications out there. It has, yesterday, it has over 80,000 packages available. The second largest was Arch Linux AUR, and it has, I think, about 60,000. So, well, there are good chances that your package is already packaged for NixOS. But if it isn't, if you really need to use some other distributions package, then you can use, well, Flatpak is supported. So you can use Flatpaks, and you can always just write a simple wrapper around the other distributions package. You can unpackage it and just put it to Nixstore as a package. But you may have to patch the binaries so they look for the correct libraries of dependencies, because userlib doesn't exist. So you may have to do a binary patch, but Nixos has facilities for that. You can use Nix for anything. It's essentially a build system. Yes, you can. The question was, can I use Nix to package other packages for other distributions? You can use Nix to package anything. I'm not sure if there are default outputs for different packages, but there are definitely outputs for Docker containers, for instance. You can build a Docker container from a Nixos expression, from Nix expression. Go ahead. I'm not sure I heard the question completely. I heard that the question is how the Nix language is in terms of stability. It's quite good. I mean, I use Helix editor and Vim mostly, and the support is there. I'm not sure about VS Code, but even this presentation software has support for Nix language, and it's like 2 years outdated. So. I mean, the highlighter, not the parser, but the highlighter is, you see the language was highlighted, and that was the internal works of this presenting software, which is outdated. So the support is pretty good, I would say. No server questions, really. Go ahead.
I have a package that needs to change the state of the system somehow. How do I achieve that?
If I have a package that needs to change the state of the system, well, you probably shouldn't use a package for that. You should use something called a module, which is a NixOS thing that defines the configuration.
It happens all the time in Debian, for instance, right? You have packages that change the configuration of the system, and you choose, for instance, between Apache server or something else, and generate
Right. If I have to choose system package like for web server? Do I choose between NixOS and Arch Linux, and Apache, and how the package tells the system that it is now the default web server? You don't do this in NixOS. You just say, I want, you basically, I can actually show you, maybe. I can show you how the live presentation is presented on my, there you go. No, sorry. This is, come on. Come on, it's lagging a bit. This is how you do that. You declare a service. Okay, I want a service that is called Nginx. I want this service to have a virtual host with this name, and I want to do something like this with it. This is how you define a virtual host in Nginx, and this is everything. This is all you need to put into configuration for a full Nginx web server with redirect in this case to work. So you don't do state changes by the packages. You do them by this. This is called a module. This is called the module services with module Nginx, which has some submodules configuration, etc., etc. There's a huge numbers of these modules. Almost everything that you commonly use is probably a module for NixOS. This is a NixOS feature, not a Nix feature, by the way. You've got something similar for your home environment using Home Manager. So that's how you do that. You don't change the state of the system by a package. That you just shouldn't do that to a stateless system, because NixOS is essentially stateless. One more question, go ahead.
If I understand correctly, you can easily replace configuration automation tools like Ansible with NixOS.
Yes, exactly. The question is, can I replace automation tools with NixOS? Yes, NixOS is by definition its own configuration tool. So yeah, since it's purely functional and fully declarative, it's you say Ansible, Puppet maybe. Those are not purely declarative languages, but for instance, Terraform is. So if you want to compare, I think one of the best comparisons would be Terraform. What Terraform is for, let's say, cloud infrastructure, Nix language is for NixOS.
So Nix does a lot of stuff, right? Build the OS, the language.
Okay. Can you start over, please, and a bit more?
So the Nix project does a whole bunch of different stuff. It's quite wide-ranging. Which parts of the project would you say are very mature, and which parts of the project would you say maybe need a bit more work or should be dropped?
Right. The question is about the state of the project of NixOS, how mature it is, what parts are mature, what parts are not. I don't feel I'm the one to be answer these questions, but if I would have to answer them, then I would say NixOS at its base, the Nix language, the module system, it's quite mature. It's been with us for, I would say, over a decade now. Not sure, but I would say that is, yeah, thanks. It's probably well over a decade now. What is new and a bit unstable is features called flakes, which I still want to talk about a little bit in a minute. And that's a different approach to Nix packages called flakes. It's still experimental, but it's been widespread, and it's, I think, pretty stable, but officially still experimental. But NixOS at its base, I really wouldn't have a problem using it in production on servers in mass scale.
Right, so you will leave the last minute to wrap up. So.
All right, let's wrap it up. Okay, one last question, but make it quick. Can I run NixOS on a mainframe? I don't know. on Raspberry Pi, yes, you can. I'm running a Raspberry Pi home server on NixOS. All right, so let me give you a few tips at the end. Learn Flakes. This topic has already been touched. Flakes is a new system for package management in NixOS and Nix. If you want to start with NixOS, learn Flakes. I didn't. I don't know much about them, and it's biting me in the ass. So do learn Flakes. The official installer, I mean, there is a new installer, it's just a few weeks old, I think, which is the same installer as for Ubuntu and other systems, but there are a bunch of other installers, so if you are not comfortable with installation, look out for the other installers, they might be easier. Use Home Manager for your home configuration, is the same declarative config as it is for the operating system. Don't be afraid to make changes, you don't break it, and once you're comfortable enough, try to install NixOS fully manually just to see how it works under the hood. There are a couple of resources. This presentation will be available later, so you can check them out, and thank you very much.
So, thank you. It seems I'm audible. So, yeah, hello everybody. Thanks for coming to my talk. I'm Miro. I work as a senior principal quality engineer at Red Hat, even though like I'm now a full stack developer of Testing Farm, so QE is just a part of it. We are also doing all the stuff from SRE to development, and we are also testing our stuff. So yeah, welcome. Yeah, small agenda, like what we will be speaking today about. So I will guide you about the introduction, not everybody maybe knows. This is what is Testing Farm. I will also tell you what is TMT and why it is important, why Testing Farm and TMT together are important for this talk. I'm gonna go through the Testing Farm request anatomy. It's just some introduction. I think there might be people who don't know this stuff, so I think it's always important. And I will dive into some interesting features that I think they are interesting, and we'll look at some use cases where Testing Farm is being used. That's on GitHub, GitLab, Fedora CI, CentOS CI, and how you can use it also otherwise. I will show you some future plans, and I hope, because the content is packed, but I speak fast, so yeah. And I will do a demo, but the demo is taking a little bit of time, so I will do some questions with it, and I think we will do it. So what is Testing Farm? Testing Farm is an open source testing system as a service, or our code is actually open, or our infrastructure code is open, even though like it's not super well contributable, but we are working on it. Sooner or later it will be that way, but it's like people contributed even from outside Red Hat. So it's basically a flavor of software as a service, and we are focusing on executing automated tests. And we are running this automated test against mostly VMs, so bare metal machines, but also containers. And we are really back-end of CI systems. If you think about it, like from the high level, that's what we do. CI systems call us to do the dirty work, provision the infrastructure, run the tests, and return back results. Testing Farm itself is being used quite a lot. We are also disease is a bad word, like something that is on a lot of places in some of the RHEL infrastructure, but also we are in Fedora infrastructure, CentOS infrastructure, GitHub, GitLab. So we are on a lot of places. We are doing the same job there, running tests. We are doing it in hybrid cloud. That's important because we have one single public API that is being used by everybody, but we have a worker deployment in Red Hat and one in public. So we are running tests also inside Red Hat, but also for the public stuff. This single public HTTP endpoint is important. We wanted to be really open source, and we didn't want to have multiple HTTP endpoints. We want to have one really and sort out all the problems that come with it. It's reachable here. If you go to this link, actually, that leads you to our documentation, and you can look how it looks like. It's fairly easy. It's still 0.1 version. We are slow, but it works well for 3 years currently, or what we are in production. Our request to Testing Farm is really easy. You specify what you want to test, and you specify the environment on which you want those tests to be run, and Testing Farm returns you back results from the high-level view. Right? That's the worker deployment that I was telling you about. Like we are, the API is public ranch. What is the worker deployment? We call that ranches because we are farm, so the worker deployment is ranch. That horse has nothing to do with anything, but I find it nice. So that public ranch runs everything I will be speaking today about. Red Hat ranch is something for internal stuff and audience, because those tests are running inside Red Hat network and providing results only to Red Hat employees. But I think it's half of half our requests. Half go to public ranch, half to Red Hat ranch. As you can see, we support a lot of infrastructure. We are running a lot of containers, actually. Actually, majority of workloads is running against containers because we run some generic tests. But mostly we do AWS, also downstream, or I mean in Red Hat also inside Red Hat network, but also upstream. We have AWS actually that connected to the internal network. We do internally OpenStack, internally Beaker. We have this nice new REST API which you can connect any other provisioning system very quickly. We have some Azure preview, and we are planning Google Cloud and IBM Cloud. But majority is this one is used just for one special device we are testing now on Q drive trees. Hope I can say that. So I will be speaking only for this part. This is about, the talk is about, I will not speak about Red Hat stuff because I'm not sure if everybody is here a Red Hat employee. I guess a lot of you are, but I will tell you that on QE Camp. So what is TMT and why it's important? So TMT, it's That's my little bit word. Maybe not everybody likes it, but it's basically, for me, it's an open source test management reimagined in Git. We did this for RHEL because we had a lot of legacy systems, or we still have, inside Red Hat, and we wanted something modern that basically the folks who are working on RHEL can easily open source tests to Fedora or CentOS, right? So they can share. And it was funny because the test could be executed on Fedora, but there was no infra actually running it. And also there was no system where you could easily consume these tests, something that would be nicely polished, that you can share the tests between Fedora, CentOS, combine them together and so on. So that's why TMT was created. It's open source. There is already like 50, 60 people contributing to it. So it's getting larger. We have, check it out. It can do for your project test management. I don't know if like who of you works in QE, but there are test case management and test management systems, usually something that you pay for. This is in Git. You store some metadata in Git, and you can do test management in it. It's pretty cool. We like it. And then we are connecting with these systems like Polarion and TCMS, what are some internal deployments of test case management systems. So we are creating some exporter plugins. So we play nicely, but we love this, that we are working with tests and test metadata in Git, because that's cool. That's what everybody does, like, correctly. I don't know, it's Git. You know, you can create a merge request again, your test cases. So that's cool. Just this is Git, right? So that's the default. Otherwise, TMT is also a CLI tool and test execution, a test executor. That's where it relates to Testing Farm. Testing Farm uses TMT to execute tests on their workers. So this test management, of course, we have a specification for it. So it's in the specification, there are few attributes that I'll be speaking about, or few levels of test case metadata. But like TMT is really focusing on that you don't need to repeat yourself. So it is basically kind of YAML format, but it's on some steroids. So you can basically store your metadata in a hierarchy. There is some inheritance and stuff. So it makes it really easy that you can like have your test configuration. Test metadata, dry, don't repeat yourself, right? Otherwise, if you go to some project which uses TMT, you install TMT from whatever operating system are you using. If it's RHEL-like, then install TMT, and you run TMT, it will discover and show you. So it's like really like we'll love it because it's like, just looking at time. You go to a repository and discover what tests are there in general, and you can have multiple unit frameworks, you can have multiple integration test frameworks, whatever, but we believe that TMT ones will like have this nice way how you can really discover all the tests that you have, regardless unit test frameworks, whatnot. TMT is actually like, for me, it's test framework agnostic. You can connect it with anything, really, even though like it also can execute tests and like has some preliminary support for some frameworks that we use in Red Hat, but people run PyTest via it, Avocado, a lot of stuff can be run in any Ruby, JUnit, name it, Ginkgo, sorry. Okay, yeah, so TMT has this, I'm not gonna go to the details much here, I will tell you in the next slide why. So TMT has like 4 levels of test metadata. One is like core attributes, which like applies to all the other levels. And then there are tests, plans. Think about tests like one test case, one that is like testing something. And then you have plans, what is like a collection of tests. And TMT where shines it that you can nicely select tests, fine-tune your test plans in a way that something only runs on CentOS, something only on Fedora, and something only on RHEL, and so on. So this comes from some use cases that we had in RHEL that we needed. Really the selection of the test is important. But you don't have to use it. You can just use TMT as a very stupid thing that runs one test, whatever. Stories, that's interesting. You can then link and create user stories in TMT. This is going a little bit beyond even test management, maybe going into the project management. But I find it useful that you can, when you go to the TMT project, run TMT, look up the stories, you can check like which stories are covered by which code, which tests. So it's like interesting. Check it out. I don't have too much time. Tomorrow we have a workshop, so come there and try it out yourself. And Peter here in the audience will do like more, we'll give you more information about this. I wanted to be really brief here because we don't have time. So how does the testing farm request look like? What's the anatomy of it? So I said that this is like really simple, right? So first you define tests. you define tests by pointing testing farm to a Git repo. Oh, that's too much. Right, so this is our API. We support actually 2 test types, TMT and STI, and if you are using STI, then migrate to TMT, please. I will tell you later on why. And the TMT is the main format. We don't support anything else, but you can see here that the testing farm can be actually agnostic. TMT is just like one execution of tests. Like we were planning to add some random running of some script or whatnot, but it was not needed. TMT now can do all the stuff. But in theory, like we could run other larger frameworks and integrate it on various levels to testing farm. So we have only TMT. You give it a Git URL, Git ref. Because it's in Git, the test metadata is in Git, you point it to that Git where it finds the test, and then we have some cool other features that are TMT specific. You can select tests directly via API. You can say that filter me these tests, filter me these plans, these tests. You can change the TMT root directory, so the directory where TMT looks up is root. It's like something like Git. Git also has like .git somewhere, right? So TMT has also some file there where it denotes that this is the start of the metadata tree. It's usually in the same root as the Git repository, but you can change it. Nothing so much interesting here, right? So the test, and then you have, yeah, that's what I wanted to say, that we are planning to depreciate STI finally. And yeah, there will be a further change proposal, maybe Fedora 40, maybe, I don't know, we will see. But I spoke with these folks who are working on this. We think that TMT now can replace STI fully. We are over it, like functionality-wise. So we hope that get rid of it because we don't want to maintain 2 things doing the same thing. Why? There is no reason. We have better, and then we can just like spend more time on making TMT better. So I'm asking you if you could slowly migrate, I would be glad. There is a nice migrate guide on TMT, it's linked here. Okay. So the environment specification, so testing farm like takes the tests and then it can run it on multiple environments. Think about running it on multiple architectures. In public we support x86, 64 and ARM. So you can run the same tests on 2 architectures. But it gets more complicated because each plan is run in a separate environment. So if you have 100 plans, then all will run in a separate VM testing farm, then parallelize it. And I think for 5, we are running now in parallel 5 on 5 VMs. And we are crunching all the plans and of course all the environments, so it can get messy. Like people are running via us like hundreds of plans, thousands of tests. If you run million, then it will break. But then we will have to fix it. Nobody just came. Like we had some people who are running really large stuff, but currently seems like it's okay. So that's the environment. In environment, you can specify a lot of stuff. So you can see it's an array of environments where you specify the architecture. As I said, look, you choose what operating system to run on via OS Compose. Then you have pool. Like one thing that I didn't mention, and I will have it in the features, like we are trying to abstract away you to knowing that you will run on specific infrastructure. You actually, like our users, usually want certain amount of CPUs, memory, disk size, 2 disks, 2 NICs, TPM support, UEFI support. Those are generic properties. Then we abstract away from the users, and we choose the infrastructure for you. Because maybe UEFI is provided by Azure, but also AWS. So we will choose the infrastructure that we want. You don't care, you just want the property, right? But if you want really AWS, then with pool you can say it. Then as a good testing system, you can pass environment variables to the test execution, any environment variable. But you can pass also secret environment variables, right? So something that we hide from you that can be useful if you need to deal with secrets, for example, uploading VM images to AWS or uploading your container image to Quiet that you build via testing farm. So we can have secrets there. It's being used. One of the features that we had to implement is installing arbitrary artifacts before the tests run. So if you are testing a Koji build, most probably you want to install it before, right? To test the real thing. So currently, like that's how it's done. You can ask for installing an array of Koji builds, Copper builds, repositories, and repository file, adding a repository file to the environment. Just looking at the time, I think it should be fine. Then you can specify the hardware, as I was talking about it, and then some other stuff. So that's roughly the test environment stuff. The environment can be influenced via this API, right? You say what you want. But also, some parts of the environment can come from the plan. So, for example, maybe in your plan you already know that you want to run against, your test. The tests in this plan need 8 gigs to run well. So you can say that in the plan. You don't need to say that in the API, right? So this combination can be done. Then, yeah, as I mentioned, the test selection. So there is an adjust core attribute in TMT where you can really fine-tune the execution for your tests. So you run only the specific environment. Something only runs on S390. It's a little bit an internal use case, but something only runs on ARM, something runs on x86, so we are ready. Like, I think TMT is very good in it, in this test selection part. Testing farm then runs stuff, and if you are integrating with a service like Packit, we have a webhook mechanism, so basically Packit is being, their API is being hit when we change the state from new to queued, running, complete, right? So they don't need to poll us, right? They are informed that something is changing, but otherwise you can poll the API, get the results. And if you are, maybe you don't even know that you are using testing farm, you just know because you get to some link like this and you can see that you are hitting our results viewer, what has been contributed by Cockpit team, thank you. A really easy, nice, like these are all plans. This is actually from TMT and you can see there are a lot of tests being run there. There is a nice reproducer. Did I mention that TMT is also a command line tool for local debugging tests? If not, then I'm sorry, but otherwise, like this reproducer, it looks a little bit larger now. It's a little bit older picture. But you can just paste, you guys install TMT, paste this in your local host, and it should do mostly the similar thing as CI does. It's not completely the same. We are on the path to making it the same. But it's complicated because on your local host, you're probably not having AWS machines, right? You have libVirt and so on, right? So then we have here some stuff about the environment preparation and installing the builds, right? We have some playbooks that run before the artifact installation, copper build installation, in this case, just copper build was installed. Post-artifact installation. You can see here also some links to API request when you can look up the details about the request. If something fails, then I have time. If something fails, then it looks something like this. By default, we show only fail stuff, because like when you come to a run, you usually want to see the fail stuff, because that's what's interesting, like past, that's cool, right? Everything should pass. So we can show the past plans here, but otherwise, we show only fail, then you can look up like exactly in the log what failed, what you would expect from a testing system, show me the failures, give me some reproducer, and you need to sort out the details. When something errors out, we are trying to be reasonable. We are not always reasonable. Maybe once we will feed this into ChatGPT and it will explain to you what is wrong, or we will fix the code so it's more reasonable. So, for example, in this case, basically, you pointed testing farm to a repo where there is no TMT metadata. So it looks like this, didn't find any plans. And it tries to give you a hint that run this command and in your repository, and you will most probably see that something is not happening. There is some -c here, that's some context, something that is being passed from the CI systems that is used in the adjust rules. So this context that is being passed, it's something that we do not auto-detect, but for example, Fedora CI is passing us some details about what architecture is being tested and distribution, and what is the trigger in this commit, and then you can adjust your test according to this context. So that's the test selection stuff. Okay, let's move on. So, like TMT, when you want to like try something on your local host, you don't need to care about testing farm at all. Install TMT, like go clone repo or use TMT init command to play around with it. So TMT is really for these local use cases, local stuff. We also now have a testing farm CLI tool which will be used for onboarding and interacting with testing farm if you have yourself a token. But we will be blending somehow TMT and testing farm in the future. We'll see. As I said, like testing farm already uses TMT, and most probably TMT will use testing farm. It's a little bit like weird, but it will work. If you are an automated system, you are using most probably testing farm to run the test in scale. So Packit uses testing farm to run tests against copper builds or without copper build installation, but run tests, Fedora CI. There is a Jenkins instance. I will be actually doing some details about this here. I will just move on. And yeah, so if you are a user, just use TMT. And once you get in the place you want to run this in CI, you will interact somehow with testing farm. Most probably you will not even need to know that they use testing farm because you will use some of our users, like the CI systems that we interact with. Sometimes you don't even know that you are really using testing farm. You will see that if you see that Oculus viewer, the results viewer. So what features are there now in testing farm? This infrastructure agnostic hardware requirements. That seems easy, but we have this beaker system inside Red Hat that has super variety of infrastructure, like bare metal machines, I mean, that have different network cards, different CPUs, and we want to get to this detail, right? So this is all fun, like public, but in reality, in real life, we have a system that is providing a super wide inventory of bare metal machines, so that it gets funny. But we are trying to get it out as a infrastructure agnostic way, so you can define it and you can say, for example, that I want only this CPU, and we will choose that CPU for you. Maybe it's on AWS, so we'll choose AWS for you. So we can run multiple environments, as I mentioned, parallelization up to 5, reproducer steps I showed you. We have a testing farm CLI tool that I have for demo. We can now request testing via it, restart some tests, if you have the token, of course. Run some arbitrary command on testing farm. Somebody asked me, like, is Linux enabled on CentOS Stream 9 in testing farm? And I told him, like, then Walsh would weep, if not. So of course it is, but with this run command, somebody can just run testing farm run on CentOS Stream 9 status, SE status, and he will see, right? So answering this simple question should be possible, so that's the run command. But we have now a reserve command, so you can reserve you as the community member if you onboard to testing farm and give me your public IP, like I will make it available to you. Later on it will be not needed, of course, we will add it automatically. But it's here, that's what I'm going to be demoing today, what I'm really glad about, that you can reserve a machine according to hardware requirements and have fun on it. We are not a funny service like some pet project. We have SLOs, we're doing DevOps stuff, monitoring stuff. We have SLO error rate less than 5%, API uptime more than 99%. Queue time, that's the new metric, so under 1 hour, but we are now under a few minutes. In public, actually, we have good infrastructure, so just that I'm not lying. This is actually an internal dashboard. I'm sorry for it. We don't have it in public yet. So this is where we are keeping the SLOs, also with other teams who are running services inside Red Hat. And we will open source it somehow, definitely, because the metrics are actually open source, but like Grafana is slow to load. Then we have these webhook notifications I mentioned. We can do secrets, variables in test execution. We can integrate with some internal other instances that somehow deal with results. Actually, the report portal is coming to Fedora. That's a system for storing results. We'll integrate with it so you can have a history of testing results. Testing farm really has just this simple view. Variables in TMT environment. I think I already had that there. Filtering plans. Did that load? Yeah, right. So the queue time is missing here. So this is for the last 28 days, like our error rate. Maybe I should slowly start opening the error budget mode. Because if we reach 5%, we drop into error budget mode, we drop all work and just go fixing the stuff. But API uptime looks, I think that's even unreal. I'm not sure why it's 100%, but it works, like we have metrics and it's not just some data. But I was surprised. Seems like we are very stable in the last 28 days, at least for the API time. Yeah, and the queue time currently, that's actually on public range. 14.2 seconds it takes until testing farm from queue goes to running. Here we need to spare money, so it's a little slower. We are still not doing the scaling well as we should. Okay, 5 minutes, and then I will do the demo and questions. So, yeah, the scale I said to you. We are running now 700,000 test requests a year. So it's like really like already large. There is stats testing for you can look it up, and it's there. This is also shows like how we were growing, from the time then we got to production. Will it load? Oh yeah. So 2020 we started 56,000 requests, 200, and we are slowly growing. Maybe 700,000 this year, slowly but surely, as more people on board. Yeah, the main use cases of our service are are basically a public service, CI service using our API to run tests publicly. Then we have Red Hat CI systems who run tests and run it, or the results are available internally against internal infrastructure. But we have also, from public to internal, this is quite locked down, but basically with testing farm, Red Hat teams can validate their merge request to GitHub against unreleased RHEL or any unreleased other product. And I think that's cool because it was very hard to do before. It's locked down, it needs to be very safe because like it's a weird scenario in these terms, but it's making sure that Red Hat employees can validate their products very early, shifting left as much as possible. That's the big selling point for RHEL, for Red Hat employees, I believe. Internally, Fedora CI, Packit, then we have some Zool integration, GitHub Actions, and the CLI tool, which you can use to interact with services. Only if you are using CLI or directly the HTTP API, you need a token. Otherwise, with this, also with GitHub Actions, you need a token. Otherwise, with Fedora CI, Packit, and Zool, you don't even need a token, like because the services take care of it. You just drop some files in Git repos. Yeah, not much time left, 4 minutes. I will do this very quickly. So Packit itself, a GitHub application that can test your pull request. It can build a copper build, and we can validate that copper build installs on the system, and then we can run tests against it. Easy as that. Report back to pull requests. I will just show a few links here because we don't have time. I was not so quick as I wanted today, so maybe that's good. Yeah, so here is Packit running, and you can see that it's testing on a lot of all the versions. I think we support CentOS Stream 8.9, Fedora, and it's running tests against that. This is actually directly TMT. TMT is, of course, like we are dogfooding as well. Then Packit can also test only. You can skip the copper build. You can just drop some files into GitHub repo, enable Packit, and you can run tests against that GitHub repo, whatever it is. You have a root, a VM, shoot yourself anywhere you can. So Packit, easiest way to run tests via testing farm. Enable Packit at TMT metadata to the Git. No testing farm token needed. GitLab is a little bit harder to set up, but also it can do GitLab. Configure number of requests in Packit, so Packit can run multiple test jobs, those test jobs, multiple environments, and multiple plans, so it can get large, but like it's possible. So Packit, you can have multiple jobs and configure it differently. It has very good configurability because Packit implemented a special field. They can patch our API, so you can do a lot of stuff with that. And you can even run tests against internal infrastructure with Packit, so if you are a Red Hat employee, it's really easy. No secret supports. That's the only limitation that I would say Packit is perfect, and I would just say like that's all for GitHub, but no secrets. There is a problem of sharing the GitHub secrets to Packit, so we'll need to sort it out most probably with HashiCorp Vault, but it needs more time. Fedora CI is having a Jenkins instance that is reacting on Koji builds, and it's running tests, and it uses webhook mechanism in Jenkins and reporting results. And yeah, if you go to Bodhi, you will see some automated checks. Everything we start with Fedora CI, it's run via us. Also, Fedora CI runs some generic tests via us, installability, RPM inspect, RPM deplin, those are some generic stuff, and they run even via containers. So, because not every test needs a VM, right? If you don't need, we can run against containers. Zool is the next CI system for testing dist-git merge dist-git PRs on Pager, and we have it actually in 2 flavors. There is also it's also for CentOS Stream dist-git contributions, but also Fedora dist-git stream contributions. There we integrate with Zool via a playbook. Once you have the HTTP API, you can integrate wherever you want, right? And we are providing the results. Zool is providing the results directly to the merge request. Maybe you know Zool. Check it out. Yeah, very easy onboarding, but this is not configurable. This is not configurable so much as it should be, and I will go to the demo. Then we have a GitHub Actions workflow. You can read what are the benefits, but rather use Packit. If you don't need secrets, with the GitHub Actions you can use secrets. And if you really need to integrate, because you write to hack or call API directly, you can use our HTTP API directly via HTTP or whatever, or you can use testing farm CLI tool, and we have on Quio a small image. You can use also that. And in future, we will have multi-host tests and easy onboarding via Fedora and Red Hat single sign-on, and more infrastructure. Grow more infrastructure because we are hungry. And now Yeah, onboard. If you want, there is onboarding guide and onboard, and now demo time. Yeah. So, I want to, this is like the newest thing. I wanted to show you it's available. If you are willing to share public IP with testing farm, then I can make it available for you for that, and it will just work. Sorry, but it will take us a little bit more time to share that public IP automatically, so you don't need to know. But if you want early onboarding, let me know somewhere. You can find the contacts in the last slide. So I want to reserve what? I want to reserve CentOS-Stream. Oh, okay, I want just Fedora Rawhide. I will just click it, okay. Fedora Rawhide, Intel architecture, reserved for 30 minutes. And now I'm open for your questions until these 3 minutes, 3.5 minutes, and I will get root and I can do whatever you want. So that's my demo. Reservations on testing farm. You can, if you have a token, you can reserve a machine and do investigation. This gets you the exact same environment as testing farm does. You might need to pass in some special parameters to make it the same as your testing as your request was, but maybe we will adjust that it reads it out automatically. So this is very cool. I'm really happy about it. I'm ready for questions.
Yeah, please ask loudly, and Miro, please repeat the question.
No questions. Was it understandable? Yes.
Do we know how many Fedora packages, use packets for testing and releasing?
So the question is if I know like how many people use this for via Packet. I think Packet has a nice slide with those large components, right? I can query the SQL database, but it will take a little bit of time. So after the, well, I'm like we are testing like I don't know hundreds of Fedora packages, hundreds, 900 was the last I checked. But with Packet, I will need to check. Is somebody from Packet team here? Maybe they know. I don't see them. They didn't come. Why not? So we will need to find out. We don't have good statistics for this, and we should have. But I can query the database after the. So no problem. Sorry. Any other question? Yes.
I'm not testing farm popular in the real product testing. I'm wondering if I have some specific requirements. Could I customize it by myself, or I can ask your team's help to customize my specific requirements?
So if you have some specific hardware requirements, you would like to, because we own the infrastructure. I own AWS account, I know Beaker. So you have a Beaker account or AWS account or?
Yeah, the real get the testing on public clouds like Azure, AWS,
Mm-hmm.
ESXi, VMware. So maybe you need some customize some specific.
Yes, I think it should be possible. Like we currently do only AWS and OpenStack, but it's internally. Public we do only AWS. So if we have accounts in testing farm, it's possible then to provision these other clouds. We have some Azure support, but others are not implemented. So if you need, for example, GCP, it needs to be implemented. So you can contribute, our code is open, or you can file us a Red Hat issue and we will try to get to it. We are all based on user requests. So if there are more users asking for GCP, we'll implement GCP. Then we are planning also to make it possible that you can give your credentials somehow to us. Then we can use your credentials because that is needed for cloud costs or whatnot. But otherwise, like we are all running this on our accounts currently. If that is not a problem, internally we have cloud cost dashboard. I can tell that your team how many dollars it spent on AWS. So if that works for you, but I'm free to free to speak after the talk, and we can sort out the details. Any other questions? Was it digestible or not? I'm just asking. Cool. That's an improvement. Last time I said that slow down the recording if you cannot understand, so it was better. I promise it will go through. Just let's wait 1 second. How much? I'm over time. 2 seconds, 3 seconds. Now it's preparing the environment. We hacked it a little bit that it shows the status. You will see that it was running, setting up, and now it's preparing the environment, and now at the end it should log in. It takes so much because our guest setup playbooks are slow, and they are updating the whole system and they're rebooting it. So that's why it takes longer. So maybe it works, and I wanted a normal machine, so I have just something, but I could provision a machine with 32 gigabytes of RAM, more disks, more disk size. But this works. If you want this, it's available on, we have actually this tool on PyPy. if you have a token, you can already use it. Just let me know somewhere that we can meet together, and I will need your public IP. But next time I will steal it, and we will make the access to you, because you need to somehow access this AWS resource. We cannot just open it for everybody because somebody in test, they set the password to Fedora, then a bot comes in and it will do something, right? So we need to make sure that this is safe. And in Red Hat, there is no problem because it's an internal network, so we are already VPN, so sorry. But if you want this, like, it's available, catch me. Thank you for your time.
Yeah, perfect. Dobrý.
Hello and welcome to the session about the new version of DNF5. And now the floor is yours, Jan, Pavla, and Jaroslav.
Okay, thank you very much. I would like to thank organizer to get the opportunity to share with you our excitement about the next generation of the software management in Fedora and other downstream distribution. Before I start, I would like to introduce my colleagues, Pavla Kratochvílová and Honza Kolárik, and my name is Jaroslav Mráček, and we are from DNF team. Well, during the presentation there will be 3 funny parts with the passing the mic, therefore enjoy it. Have fun.
Okay, so first, so that we are all on the same page and know what we are talking about. So DNF is a package manager, which means basically software for installing, removing, upgrading other software. And to put it a bit into context, on the lowest level you have RPM, which does the actual installation and removal. Above it there is DNF that uses RPM and does other stuff, like it understands repositories and modules and uses libsolve to resolve dependencies and so on. And above it there is PackageKit, which is DNF daemon, and that is used by some graphical user interface tool. Okay, so this presentation is about DNF5. But first, let me just shortly talk about its previous version, about DNF, so that we know why the DNF5 was needed, what was the motivation to move to the next version. So in here you have the structure of the original DNF. So this is not DNF5 yet, okay? And you can see it's a little bit complicated. In the middle there is this big box called libdnf, and it is containing other smaller boxes. And that's the DNF library. And you might think, okay, it's somehow logically composed of small libraries, but it was actually the other way around. So first there were these small libraries, and it was then meshed together to form libdnf, and so you might see how that might be a problem, because there remained some duplicities it didn't like fit together very nicely. There was lots of work done on it to work properly, but still, like it's not perfect, right? Then you can see in the purple boxes there is package kit. I already talked about it. It's the DNF one. Then there's DNF. That's the command line tool, and there is micro-DNF, and that's another command line tool. Right? So you might ask, why do we need 2 command line tools for this? And the answer is they're both a little bit different, right? DNF knows can do a lot of things. It has a lot of features, but it also needs Python, and so it's not very suitable to use in containers and when you want minimal installation. And that's where micro-DNF comes in. But micro-DNF, on the other hand, doesn't do everything that DNF can do, right? Also, like that's because of they both use different parts of the library, and so, for example, when a change is done in DNF, it doesn't get automatically done in micro-DNF. Again, you can see how that can be a problem. And last thing you can see there is that there are two plugins. And again, there's duplicity there. There's C plugins and Python plugins, and there's all overlap in functionality. Okay, so you can see there's a room for improvement. But we got to a point where it was very difficult to make improvements without breaking compatibility. So this is where DNF5 comes in. And yay, now this is DNF5 structure. And you can already see it's much more simple. The big box is just the library doesn't compose of different sub-libraries that don't fit together very well. It has completely restructurized API. It's written in C++. And you can see that there's, again, like DNF5 daemon that aims to replace package kit. And there's only one command line tool, which is DNF5. DNF5, like the command line tool, is now great because it has all the features that DNF had, but it's just as lightweight as micro-DNF because it no longer depends on Python. But don't worry about Python. We do have Swig bindings, and so it can still be used via them. And it's really great because like all of these 3 things use the same library and not its different parts. So one change can be used for all of these. As last thing, you can still notice that there are actually 2 boxes for plugins, but that's okay because now these are actually different. There are C++ plugins for the library, and then there are plugins for the command line interface. So, for example, adding a new command would be there, while something that would alter the run of the whole DNF would be in the plugins for the library, and it could be also used by the daemon. Yes?
The current DNF plugin compatible with DNF5?
Could you please repeat the question?
Sorry, what?
Current DNF plugins, will they be compatible with DNF5?
Current DNF plugins, if they will be compatible with DNF5. Yeah. I believe not. Yes.
So the API is not backwards compatible?
Yeah. Yeah, so they will need to be rewritten, but we are rewriting many of plugins, right? Okay, I will hand over to Yarda.
Okay, there's another question.
The CLI plugins, do they use the Swig bindings or do they directly written in C++?
Could you please repeat the question?
Well, the question is whether CLI plugins use Swig or whether...
Are they directly embedded in C++?
whether they must be in C++. Yes, they must be in C++. The reason is quite easy. Yeah, if anyone will write an important plugin for your distribution in the Python, then you will depend on the Python, and then you will lose one of the advantage of the whole stack. Therefore, for us, it's much more better to write or to help you to convert your Python plugin into C++ than to support Python interface for the command line plugins. I'm sorry. Let's wait for the question and answer section with other questions. Maybe it will be better to have it at the one place. Thank you. Sorry. Well, when we talk about improve API that we suppose our new library will provide, what it means. We try to provide better workflows, safer workflows. What it means that if you run things incorrectly with your new code, DNF5 should alert you, stop you, and explicitly say you do things wrong. You should call it in a different order. Why this is important? We have experienced many reports from the users like, it doesn't work. And the simple answer is you run things not according to the description in our man pages and so on, therefore the workflow was not guarded. Or even worse, no one reports anything and you think everything is working according to your settings. For example, you modified settings at the time when it makes no sense. But then every time when you ask what was the setting for the operation, you received a new value that was not used for the operation. Therefore, that's why we have some locking mechanisms, for example, for the configurations. Of course, we also improved transaction reports. Well, former DNF4 use or overly use logging. Therefore, if you have any problems, then look to the log. But your application is unable to handle such a report because parsing anything from the log, well, it's awfully wrong from all sides. Therefore, if something will get incorrect with your request for the transaction, then there is a structureless logger, and you can list it anytime and make a decision according to the log rather than to just depend on the return value from the transaction resolvement. Well, what is also different? DNF itself has its own configuration, but if you use API, you will discover that many configurations, many API methods requires passing configuration directly to these methods. The reason is, as Pavla presented, difference between C and the Python part. Configuration is in the Python and the logic is in C, and it's not capable to pass the original structure defined in the Python. What it means, you need to pass less arguments. It's more transparent. Therefore, you cannot have a configuration and use different set of the values. Sometimes you can override it, but again, it will be transparent. Therefore, you can get the original value that you use for the request. Well, with what we also did, we try to listen to you, to the community, what you need. In past, we closed many your requests that, we cannot do it right now. But with the design of the DNF5, we remember these, your use cases and try to modify the design to be able to provide or to support additional use cases. It means that we try to use less hard-coded settings and values in our code and move these values, for example, for the transaction to the configuration. Additionally, well, during the looking to your code, to your projects, we discovered that, okay, you have some bundle of our code. Therefore, sometimes it makes sense to provide it as API. Then you don't need to, for example, parse arguments. It's like, I would like to behave like a DNF, but, the API or the argument parser is not available. Therefore, okay, let's use the same logic like DNF does. And then our users will get the same touch with, like with the DNF. The problem is that it's, again, code bundling. And we usually improve this code because we find some edge cases when original parser failed, but it's not updated at your site. Yeah, it's hard-coded your parser at your application, and you have to maintain it, and usually it differs. Well, there are, of course, many improvements in DNF5, and let me just share few, for example, performance improvements. For example, one of the site is loading of the repository. With the DNF, you can see that it downloads the repository, and then it somehow freezes, and then it continues with another one. And that you cannot experience with the DNF5. The trick is that we split downloading and processing metadata into two processes that run in parallel. That runs in parallel. Yeah, sorry. It means that when you download the first repository, you directly start with the downloading the second repository, and the first metadata for the first repository gets processed by our solver. This is not only improvement. Another thing, and very important thing, is that the DNF5 does not download a file list by default. File lists are really huge piece of the metadata, the biggest one. And DNF5 is not downloading these things. It has two sides. I mean, less downloads, less requirements for your hard drive, and infrastructure also is used much less. Okay, downside is that in some cases, data will be not available. It means that some packages that, for example, requires some strange files, it's against, for example, Fedora guidelines, they will have a problem because DNF5 by default will not see these dependencies as satisfied because the metadata that were used by DNF are simply not available for the DNF5 in default setting. The good news is that if your downstream, if your third-party repository requires such a metadata, it's configurable. Therefore, it's not hard-coded. You see that you end up, you need it, okay, then you will pay the price. But we should not pay the price for these rare, or hopefully rare, use cases on all systems. Oh, additionally, I have few examples of the performance improvements because, and this is the, let's say, the long improvements in our DNF stack that, well, we improve according to the DNF, and of course, DNF4 was much faster than DNF2, and DNF2 was much faster than DNF1, and it is much faster than YAM in many cases, especially for the transaction. And we continue with the same way. Therefore, well, as you can see, well, even repo query, if you ask for the multiple arguments, or if you run, for example, what requires with the repo query, or even the update with many arguments, there is a huge difference. But please take it as an example. Yeah, there are many differences, and hopefully you will get satisfied with the results. And well, let me move to our roadmap because I think it's also important. Where we are at the Fedora 38, and what happened at Fedora 38? Micro DNF was obsoleted by DNF5. You know, no one complained, and we have received not complaints if this for this change. It means that if you install new containers, well, you will have a DNF5 inside. Well, also, what happened? Well, of course, the Fedora, that's one important information. Fedora 38 was also a milestone for the DNF5 project because this is the first time when it appears in Fedora repositories. Well, upcoming release, Fedora 39, what happened? There is a huge change because DNF5 will obsolete DNF. What it means? By default, anyone will start by default using DNF5. Also, this is the time where users of the command line interface It means other components are supposed to work on the adoption of the DNF5. It means if your app is using anything from the DNF, then, well, check, verify at this stage before the release of the Fedora 39 that everything works with the default package manager and distribution, it means in DNF5. If it doesn't, well, then please report it as soon as possible, because there is nothing like unresolvable problem. You know, we are engineers. Yeah, resolving problems, it's our job, not creating new one. But if you will not report to us what you need, then we cannot help you. Sorry, guys. The next release, okay, Fedora 40. Fedora 40 is the time where we would like to obsolete microDNF or remove microDNF from Fedora. We will set up the standard process, you know, that's obsoleting or retiring a package. It's the standard process of Fedora. And I'm using this channel just to share it with you because it is important. Get ready. If you depend on something that is not provided by DNF5, please let us know. Yeah? We are taking these requests as a priority. It means if any other software is blocked or adoption of the DNF5 is somehow blocked, it's our priority. Well, I've heard several times why we are removing any functional software from our stack. And the answer is, I remember YAM. I remember when and in which state we remove YAM from our distribution. Well, it was removed at Fedora 31. And at that state, it was completely broken. The problem is that if you will search on the internet what to use with the Fedora or RHEL, often you will get a YAM. Therefore, you will install YAM, you try to use the YAM, and then, you will get tracebacks. Yeah, because it was not functional, and that's what we want to avoid. Remove software before it gets broken from the distribution, because microDNA is not going to be supported by upstream. And the next step, the next main milestone is, of course, the removal of the DNF. DNF from the Fedora repository from the same reason. Therefore, if your application depends on DNF API or libDNF or Hockey API, then during the Fedora lifecycle, that would be good if you will start or if you will finish adoption of DNF1. What's the risk? Standard process in Fedora when you remove the package is, well, you know, we are not going to support it, and, well, what's other option? You can take it. Yeah, you can take it, you can start with support, but, you know, you have to support. Yeah, that's the trick. Therefore, thank you very much, and I'm passing the mic to our last speaker.
Do you hear me? Yeah, great. Okay, so let's see the DNF5 in action. First, we have prepared some command line examples comparing the original DNF with the new DNF5 experience. So we have prepared like two separate containers, both with the same configuration, and on the left side I will show you the commands using the original DNF, and on the right side I will run the same commands using the new DNF5. So let's start with some common usage, like installing a package. So we can install, for example, the glibc devel package, and the same one with the DNF5. And what's happening now is that yeah, the DNF needs to fetch the metadata from remote repositories before being even able to tell that the given package is available. So we have in the system configured the links to remote repositories, and from there we are like downloading the metadata files about what are the packages available, what are their sizes, and what's the relationships between the packages. And we can see the first, the difference that Jarda was talking about when we look at the Fedora 38 repository. There is like 34 megabytes downloaded for DNF5, while for the DNF there is like 83 megabytes of metadata downloaded, and it's mainly because of that files are now not downloaded by default. And here we can see also the calculated transaction, or in other words, what's going to happen if a user confirms the installation. So DNF tries to find like the best available way how to install the package of the given name. And if it wouldn't be possible, it tries to provide the reasons why it is so. And we can also see some differences in the output, like we have some more information regarding the DNF5. There is like what is being replaced, and also the sizes here now refers to the installation sizes of the packages, while in the DNF it was the download size. Yeah, so we can just install the packages. You can see that there is some connectivity issues, but yes. So yeah, there are some changes in the output, but hopefully for the better user experience now. So when using the command line environment, we don't probably want to type a lot. So in the DNF, there was already some support for autocompletion, where we, for example, want to autocomplete the mark command. We are provided with some suggestions there when we press the double tap. But if there is some subcommand for the given command we want to use, the DNF doesn't provide any suggestions, and instead it incorrectly provides already the installed packages as the argument for that. We can try the same thing for the DNF5. You can see that the mark command is also completed, and also the subcommands are provided for the user, also with some brief description what each command is doing. So this is also hopefully for the better experience. And now let's try to compare how fast is querying the information about packages. So we will first run the most simple query command, which is the DNF repo query, which basically lists all the available packages from the connected repositories. So we can just run it for the both commands. Yeah, we could see that there was like a little bit faster for DNF5, but we can measure it precisely using the time command. So we can use DNF repo query, and also we will suppress the output, so we will actually really measure the execution time of the command. And the same one for DNF5. Yeah. And we should see there the improvement. Yeah, there is like more than 2 seconds and less than 1 second for the DNF5. We can also try something a little bit more complex. So we'll list all the packages with what depends on libcurl library, and the same thing for DNF5. And there the difference should be more significant in this case. Yeah, there is like 6 seconds for DNF5, and there should be like more than 3 times slower for DNF. Yes, it's like 18 seconds. Okay, now let's try the same use case as I shown before, the installing of a package, but now using the DNF5 API. So this is how a simple Python script installing some of your favorite package looks like, but let's look at it step by step. So first, we need to have installed the DNF bindings package for Python in order to simply import the libdnf5 library like this. Then we need to create a base object like the center point of the DNF and tell that we want to load the configuration file from the default system config file and applies it. Then we need to prepare a data about repositories. So we prepare a stack with the data about all connected and configured repositories from the system configuration file, and then we will download the needed metadata and parse it into the objects. Now we have like everything prepared to tell DNF what we want to do, or like what is our goal in the scripts. And here it basically means installing a package of a given name. In this case, it's the Nudoku package. It's a simple Sudoku game for the CLI environment. Then when we have the goal specified, we can resolve it, meaning calculate the whole transaction, what's going to be installed, removed, or upgraded, which is followed by downloading the needed packages from remote sources, and then actually running the transaction, which will perform all the needed actions in the system. These two actions here are separated because in some use cases we actually don't want to change the system and, for example, just download the packages, right? So now we can just run the script. I will just show you that there is no Nudoku command yet, and I will just run the API script, and it will like simply just install the package. Hopefully, maybe, and yes, it should be now installed. And here we can play the Sudoku all day long in the CLI. Okay, nice. Okay, so now we are heading to the end of the presentation, so I will like to briefly introduce our core team members that are participating in the DNF5 development. So here, Marek Blaha, David Cantrell, Evan Goody, there are our presenters today. Aleš Matěj, Jarda Mráček is our great tech lead, Jaroslav Rohel, and Nicolas Sela. And I would like to also mention our QE team. I think we have like a nice and tight cooperation with them, and they help us improve the CI stack and implement the API tests for the Python. And now I would like to invite you to connect with us and collaborate on our projects. Our main interface is on the GitHub channel, so we have their issues, which we would like to invite you to discuss what things are bothering you and what you want to improve, the pull requests, their review process, and etc. And also we have we try to make label all the things we think that are good for the new contributors with a good first issue label. So watch out for these. On the Kanban board, you can see all the progress on the work items, like what is being reviewed on, what is work in progress, and what's planned to be done soon in the to-do list. And for general Q&A, there is the discussion session. Also, we are on the Bugzilla, which we watch these for the Fedora bugs. So, yeah, and we triage all the items from these channels regularly every week, so we can provide the answer, like the response to reporters quite soon. Okay. So, thank you.
Neil, you have the first question. Go on.
So you turned off the file, fetching the file as XML by default, but why not be able to process the files that are in the primary XML, because that's still useful stuff and we're already downloading it.
I mean, we load that.
And please repeat the question, ideally to the microphone.
Yes.
Well, the question is that we turn off downloading file list by default, but why did not we use file list from the primary? Is it correct? We do, with us. Okay. We do. Yeah, therefore, everything what is in primary, yeah, we read. Therefore, if you require, it means that if you require something from etc, from the configuration, or if you require binary from user bin standard directory, it's not formal Fedora, yes, weird, yes. Everything will work like charm, and you will see these files provides.
So follow-up for that. If you do something like repo query, does it download on demand the file so you can do the queries?
Yeah, the question was when I run repo query, whether it downloads a file list in background. Well, not yet. But for example, if you request a file, I mean install any file, DNF automatically downloads a file list. Okay. Therefore, this already is present, and I think we will extend. For example, if you want to list files and so on, that there will be a logic, but it will take a time to implement it everywhere.
Sounds good.
Oh, I don't know who is there. Maybe it's Bishek.
So you mentioned that there were no regressions from DNF. But I heard a story, I'm not sure if it's true. So the first part of the question is whether this is actually possible. That microdef was using less memory than DNF5, and then small containers have trouble with the upgrade.
I'm sorry, can you shorten the question?
I heard a report that DNF5 is using more memory than micro-DNF.
You mean hard drive or RAM? RAM. Well, the question is, that there are some rumors that DNF5 is using more RAM memory than micro DNF. I think this is not true, yeah, because micro DNF by default download also file lists, and the most requirements for the RAM is a file list before you process them. Therefore, it means there should be a significant decrease in the default behavior of DNF5 in any operations.
That sounds great. So,
but you cannot count on that. I mean, if a user will try, for example, install a file, then it will download the file list, and again, it will require additional memory for processing these metadata.
Yeah, but if you're doing this smart thing, then you don't need to memory.
Yes.
So, there are some movements in Fedora to stop using modules. What are the plans for the support for modules in DNF?
Well, we have no other choice. Oh, well, the question is that there are some rumors that modules are going to disappear. And the question is, what's the plan for the DNF team? Well, we have no other choice. We have to support, for the legacy reason, all modularity use cases, because it is expected that on one system you will be able to handle non-modular and even modular stuff. Therefore, we have no other choice than to implement modularity like it was in DNF.
So we are over time, but last one question.
Last more question. Okay, well, that's short answer. Well, you can read the history in the Fedora Devel, and you will find why. Well, the question is why not Rust? Yeah, the long answer: Rust wasn't an option at the time when we start with the development of DNF5, and we have good reason why to not start. Short story, long story is on the Fedora Devel. Please read it. And thank you very much, and please don't hesitate to ask questions after the session. Yeah, we will be happy to answer any of them.
Yeah. Okay. Welcome. I hope you are all here to contribute to CentOS Stream kernel. And maybe not. Maybe you just like get inspiration or maybe get scared away by what we have and what we have built. Anyway, today I will explain how people external to the RHEL or Red Hat kernel teams can contribute to the CentOS Stream, and by means of RHEL taking the CentOS Stream to the RHEL kernel. So first, I will spend a few words about what is the kernel package in CentOS Stream. It's a package as any other, except it has some specifics. So it's RPM. It's actually a set of RPMs, but the specifics are that the source repository for the kernel, the Git repository where the work is done, is not the repository from which the RPM is built. This is different to most packages in CentOS Stream. So it has separate repository, more on that later. Second difference is that the work on the Linux or the CentOS Stream kernel is parallel. So imagine like bunch of, number of surgeons working, operating on the same body at the same time. One of them is like maybe updating the circular system, replacing arteries with something better, while another one is replacing a leg at the same time. So there are some challenges, especially when the arteries go to the leg and they have to coordinate somehow. Just to give you an idea how massive it is, I checked yesterday. So currently we have 149 merge requests opened for CentOS Stream kernel 9. Yeah. Some of those have several hundreds of commits in them. Of course, to have all of this to be manageable, the kernel teams have to establish some processes around that, because it wouldn't work otherwise. So there are custom rules, custom processes that needs to be adhered to if you want to contribute. On the other hand, the benefit of all of this is that we basically need a dedicated person to maintain all of that, to merge the stuff, to take care of the building the packages, pushing that to the distgit, to the repository from which the packages are built. So we have a dedicated person, or maybe even persons for that, and they deal with the CentOS Stream processes themselves. Yeah? So the distribution have some processes, but the contributors to the kernel don't have to deal with those. So we basically exchange one set of processes, one set of complex processes for another set of complex processes. Yeah. So this is the introduction. In order to understand what the work entails, what are we basically constrained by, let's first talk about the expectations. So let's take a user of CentOS Stream, user of RHEL. Yeah, what they expect from the kernel. Of course, stability. What does that mean? That means no regressions. Stuff that worked before should work after a kernel update, right? Well, it's more. It's performance. No performance regressions. The user probably wants, after update, for his work or for their workloads to work as fast as they did before. Yeah, so performance regressions, no. No API changes, of course. If you have a program and then update the kernel, you still expect your application, your program to work. Yeah? And basically, every application interacts with the kernel. So the APIs that the kernel provides to applications should not change at all, yeah, right? This is what you expect. Well, then we have kernel modules. You may be using third-party kernel modules, like NVIDIA driver, for example, for your graphic card or whatever. And you want those drivers to work after the update, right? So after the kernel update. Yeah, so the problem is that those modules, those kernel modules, the kernel drivers, they are using the internal API of the kernel. So you want this application binary interface between the modules and the kernel to not change at all, right? Well, it turns out that some people want more, not just the binary interface. They want also the internal API, which means I take the driver source code from the old version, update the kernel, and compile it against the new kernel, and it should still compile. Yeah, sounds like the same, but it's actually a very different thing. No behavioral changes, of course. I want the stuff to run exactly as it was running before the update. So yeah, in short, do not touch the stuff I'm using. Yeah, Red Hat, please keep your hands off my stuff. And also, please bring me new features. Yeah, we want the newest, shiniest. Yeah, so please, give us what we need. There's that new hardware we bought. We want it to work in your next release. So please update the drivers for us. Oh, and we also heard about this cool new feature that upstream kernel has. So please bring it too. Yeah, update the core, update please update it. Please update everything you can, except for the stuff I'm using. Don't touch that stuff. Yeah, now do you see the problem? That my stuff is different thing for different users. So everyone wants us to update everything except for this stuff. So this is the situation we're in. We need a compromise. Of course, we cannot deliver all of that at once. So the compromise that we arrived to, it's a compromise. Nobody is happy about it. But apparently people are still buying RHEL and using CentOS Stream, so it's not that bad. So the compromise is no functional regressions. If something worked before, it should work after the update. Performance, yeah, we should not regress performance, but imagine cases when you do something and you improve performance for 90% of users by a lot, didn't touch the performance for 9% of users, and for 1% of users, you slightly slowed down their workloads. Is that okay? Is it not? Who knows? Yeah, so there's some kind of balance. So yeah, but probably slowing down networking for 90% of people or slowing down disk or storage reads, that's probably not acceptable. Then, yeah, of course, the user space API that the kernel provides to application, that should not change, but it should not break. Yeah, so we can change it if we maintain backwards compatibility, probably. Or if nobody notices, that's okay as well, right? The kernel modules, yeah, they should probably work, but here is a problem. The kernel development upstream, yeah, the community kernel development, it doesn't care about internal API stability. It changes all the time. The interfaces inside kernel and to the drivers, they are constantly changing. So if we are to bring in some new features, we cannot keep this interface completely stable. Yeah. We can try to maintain some backwards compatibility, but it's like a lot of work and nobody's enjoying that work. It costs a lot. So yeah, so we have to limit somewhere. Again, it's about finding a balance. We also are updating drivers. Not all drivers, obviously. We don't have infinite people working on the kernel. But we are updating drivers. But again, sometimes updating a driver means bringing in a new kernel core feature that the driver is using. Yeah, so there are dependencies. And it's not always easy because sometimes bringing in some new feature from a stream, it's risky. Yeah, we risk stability, we risk introducing regressions. So again, it's kind of balancing act. So we might update drivers, but maybe not enable all the features that the hardware supports. And of course, we updating the kernel core features. Again, balancing that with stability. Not everything is possible without compromising the other stuff. So yeah, as I said, nobody is happy, but hopefully it's good enough for everyone. How does this work in practice? When we started, and now I'll be talking mostly about, or basically only about CentOS Stream 9, but it applies to also the other streams. So for CentOS Stream 9, we had, when the development started, there was a kernel, was 5.14, and the CentOS Stream 9 is still on this kernel, yeah, even those years later. So we have kernel 5.14, but we're backporting stuff for upstream. We're taking commits from upstream and applying them to the kernel. And that ranges from single bug fixes for like simple stuff, single features, to like large rebases of all drivers and whole subsystems. So for example, for you to know what I'm talking about, the XFS file system is up to the upstream kernel 6.0. The USB subsystem, all drivers, the core, like everything, is on par with upstream 6.2. You know, the latest kernel release upstream is 6.3, so this is pretty new. BPF subsystem, yeah, this is pretty core stuff that's like connected to really memory management and all of that. It's 6.2 in the kernel, in the current CentOS Stream 9. Wireless, including all drivers, 6.3. Multi-path TCP, 6.4. That kernel is not even yet released upstream. Yeah, so you see, all the different stuff is kind of sewed into the kernel, yeah, replaced different version, and yeah, so maybe you get the Frankel kernel terminology now, or technical term now. This is what we have. It works. It works, but, oh, one thing I forgot, and I will stress it multiple times. We are taking stuff from upstream. That means everything, almost everything, we strive for everything that we have in CentOS Stream to be upstream. We're taking stuff from upstream. Everything needs to be upstream first. So, as I said, all of this can stick together and work reasonably only thanks to several things. First is the processes we have around that I will talk about in a minute. And the second and very important thing is testing. So this is the testing that happens whenever a single change, be it a single bug fix or that large rebase, whenever it is applied to CentOS Stream kernel. First testing happens when a developer does the work. So when we backport stuff from upstream, yeah, or when we develop stuff upstream and then backport it. So this is where the first testing happens. Yeah. Obviously, nobody wants to just push over the fence untested stuff. Then automatic testing kicks in. Yeah, we have CKI. There were talks about CKI in previous DevConfs. If you are interested, you can find the recordings online. So this is continuous kernel integration testing, large test suite with a lot of infrastructure around that. So this is run. We have NSTIF, Linux network stack testing, which is specifically for testing networking both functional performance. And we're adding more over time. So this is run automatically. Then there's pre-verification, which means before the change can be merged to the kernel, a human, and hopefully, or maybe automation, if it's there, if there is automation for the particular feature or particular bug. But someone else than the original author, and it's important, tests this. And if it passes, only then this is merged to the CentOS stream kernel. Then there's integration testing, because it's nice that you tested one feature or one bug in isolation, but it can interact with those other 150 parallel changes to the kernel in weird ways. So once this is merged, we need to test again to see whether it did not conflict or did not got influenced by other stuff in a negative way. And last thing is proper QA testing done by QE engineering. That's really comprehensive testing of the whole kernel and all the features and everything. So that's a lot of testing. Okay, so with that cleared, let's look how it looks from the point of view of the contributor to CentOS stream kernel. The centerpiece is the merge request. We're using GitLab for CentOS stream, not just CentOS stream kernel, but the whole CentOS stream development. So this is the URL of the CentOS stream 9 kernel source repository. So this is where the development happens. It's completely public. You can go there. You can watch what we are working on, and of course contribute. So merge request against this repository. That's basically the centerpiece around which everything is built. However, before you can open a merge request, you need to do one important thing, and that is to file a bug or issue. Every change we do needs to be tracked. So you go to Bugzilla or Jira, doesn't really matter, file a bug or open an issue there. Be sure to select the proper product, component, subcomponent, product Red Hat Enterprise Linux 9, component, obviously kernel, subcomponent in Bugzilla, whatever you think is the best fit. The reason for that is you want your change, your merge request to reach the proper team. And in the bug or in the issue, explain why you are doing that. Explain the benefits of it. Why it's important. If you come as a contributor to CentOS stream kernel, it's not the amount of work that is connected to the contribution. It doesn't end with submitting patches, submitting commits. There's more. There's testing I talked about. Someone has to do it. And there's maintenance. Someone needs to maintain that stuff for the whole period where Red Hat Enterprise Linux is maintained, which is many years. Yeah, so submissions don't come for free for Red Hat. So explain benefits, explain why the change is good. And also, because it means work for other people, try to make it easier for them. Provide detailed testing steps. Yeah, so the QA quality engineering is okay with the change because they know, okay, this won't be that much work for us. Don't forget to note that you will be submitting the merge request. So you are not asking the developer to do the work. Yeah? Make it easier for them. And be mentally prepared for the option that it might be rejected. So we have a bug or issue. Then now let's do the work. We clone the repository as usual from GitLab. Yeah, create our own branch based on the main branch. This is where the main branch is, where the development happens. Apply our patches. Now, let's stop at that. And now this is the first thing about the processes. The commit messages, they have some mandatory format. I will explain it on next slide. Yeah, so it's not like free-form commit message. So that's first thing. Second thing, apply upstream commits one-to-one. Yeah, so one upstream commit is one CentOS stream commit. Do not squash commits together. And of course, it's a Franken kernel, so it's unlikely that commit from upstream will apply as is to CentOS stream kernel. Most likely, some commits do if you're lucky, but most likely you will have to do some changes, adjust to the old APIs that are there or something. Those changes need to be explained. Yeah, there should be reasons why the backport differs from the upstream. Let's look at the example. This is a real commit from CentOS Stream 9. Let's see. First, the mandatory fields, mandatory format. There must be a Bugzilla or Jira link in every commit. Every single commit must have this line. And in this format. Yeah, it's parsed by machines. So even training white space is a problem. Yeah, you will be taught, so it's not it's not entirely black box, more on that later. So this is the first thing. Second thing, as I said, the policy, there is upstream first policy. So everything that we bring to a CentOS stream kernel must be upstream. This line actually says this is the hash of the upstream commit, this one is backporting. Yeah, so, and again, exactly this format. It is parsed by machines. Third thing that's mandatory is the signed off byline, which has some legal implication. If you're not familiar with the certificate of origin, see the documentation. Must be there. And here, I will point out this section. This is not passed by machine. This is for human consumption, for reviewers. Yeah, so this is free form, except the conflicts line that must be in this form explains what was changed compared to upstream. Yeah, so this is an example how it looks like. So you apply patches, and then you can finally submit a merge request. Yeah, the usual GitLab workflow, nothing you are not familiar with. So basically you fork, add remote, push to your remote, open merge request using web UI or API, and you're done. Almost. In the merge request description, you have to repeat two things, the Bugzilla or Jira link and your sign off by line. When you do it, then the automation kicks in on GitLab. Kernel is built and it's tested. If you are an external contributor, then only limited tests are run. It's not full test. It's for security reasons. Once your submission is reviewed by someone from Red Hat, they will start the complete pipeline. We don't want the code compromised by external contributions, obviously. Then also some automation is run, which will do checks on the submission. It will check whether the fields I described, like all that Bugzilla entry and so on, whether it's present. If not, it will tell you in a comment in the merge request. it will check whether the Bugzilla or Jira issue you filed, whether it's in proper state. There's something you cannot influence. Someone at Red Hat has to put that in the correct state, the bug or issue. Another check is for missing fixes. So if you backported something from upstream and there was a follow-up upstream that fixed that, you will get, and it's not there, it's not in your submission, you will get notified. It will also check for conflicts between submitted merge requests. It is quite important given the amount of merge requests we have. Then there will be some labels added. Actually, quite a lot of labels. So this is an example of one merge request. There are subsystem labels here. Basically, those indicate which subsystem were touched or were modified by your submission. This is a large merge request. Yeah? It has, I don't know, like 300 or 400 commits. Yeah, so it touches a lot of subsystems. There are labels with the current state, like XNet needs review or CKI and so on. It will also add approval rules to GitLab, to the merge request, meaning will list people who should review the merge request, and it will notify them. Then review happens. This is important part, but there's nothing surprising. So someone from Red Hat or from community will review the commits you submitted, will make comments. Now it's important to respond to the comment. If someone has objections or ask for explanation, provide that. The discussion happens in the merge request, yeah, in the comments there, and finally when it's reviewed and everything is ready, the merge request is ready for QE testing. That means you get all of these labels in the OK or warning state at worst. So your commit description is OK, no merge conflicts, the CI testing succeeded, and somebody, or like all the approvals were given, all the needed reviews were done. Then, and Bugzilla and Jira is like in prepared for testing state, you get ready for QA. Then the testing happens, the pre-verification, again, done by someone else than you. You will probably agree in the Bugzilla or Jira who will do the testing, whether it will be Red Hat or whether someone from your company or your friend provides, or your friends provides the testing, whatever. Then, if then it's done, then you get Bugzilla or Jira OK, ready for merge, and boom, it's merged. Or the maintainer will merge it. One short notice, sometimes if for example, if there is a driver update, it might depend on other changes in the kernel. Yeah, so if you, for example, update the networking driver, yeah, your favorite networking driver, to the newest version, it might need some changes in networking core to support new protocol, perhaps, or something. So that's a different merge request, of course. It's not the same stuff. So different merge request needs to be filed for that. And to save us time, you can actually submit those merge requests in parallel. You can depend on other merge requests which is not yet merged by pulling the code, applying your patches on top, and submitting that. The only thing you have to do is put this line to the merge request description that you are depending on this particular another merge request. And then the automation we have will be able to figure it out, find out that like what is the first commit that is really part of your merge request. So that's like top of the dependencies. We'll put this label there, and then you're good. The only problem is GitLab is not aware of that. Yeah, this is a feature that is missing in GitLab, so we implemented it ourselves, and as a consequence, it's really hard to impossible to use the web UI. I will, yeah, okay. 15 seconds. We have tools. that will help you with that. Lab is a CLI tool that helps with submitting merge requests. And we have Reviewmatic, which is a custom tool that helps with reviews, that understands the workflow we have. So that's it. Here's a link for full documentation of the process if you're interested in details. And now questions.
Please ask questions, and Jiří will repeat them to the microphone, or Zdeněk can read the questions from the matrix chat, if there are any. Nothing yet.
Yeah.
It seems to me that you as a company are repeating internally a lot of the work done on the kernel.org long-term support kernels. Would this not be simplified if you stuck to long-term support kernels for real?
Yeah, so the question was that by doing the backports, we are repeating the work that upstream does with the LTS kernels, and better it would not be easier to use them. The problem is that the quality of the upstream stable kernels is not satisfactory, or at least this we found. There are things like machine learning involved, which selects which commits are backported, and also basically whatever someone thinks is desirable for those stable kernels is thrown over the wall and applied. And it does not mean, this does not meet the stability and no regression guarantees we need. So we really want all the stuff that's going into that to get reviewed by us. Yeah, and to be tracked, to have someone who's responsible, that like we can go back to say, okay, yeah, look, you broke it, you fix it. Yeah. So all of it together, we found out it's like for stability, it's basically no go. Yeah, there's a question.
For the integration test, what specifically do you run? Do you like next to the upstream kernel test suite? Is there one?
Yeah, so the question was what the integration testing consists of, what it is. Basically, right now it's done by CKI again, but it's like a larger battery of tests. There's a lot of different test suites there. I don't remember off the top of my head, but there's LTP and like many more.
Are they open source as well?
The question was whether they are open source. I believe so. I'm not 100% sure of everything, but I think so. Please don't like, yeah, I'm not sure. I'm not sure.
Okay, and with that, we can wrap it up. Thank you, Jiří.
Thank you.
Thank you. Hello, everybody. Have you ever wondered what does it mean to maintain an RPM package in Fedora, CentOS, CentOS Stream, RHEL, or any other? If so, I will try to answer some of your questions today. I'm a little bit afraid that I will open more and more questions than I actually answer, but I have plenty of time after the talk so we can discuss it. My name is Lumir. I'm from Python maintenance team in Red Hat, and we maintain Python packages, quite a lot of them. So without further ado, the agenda is kind of packed. I'm not sure I will manage it in 25 minutes, so I'll try to do it quickly, but we have plenty of time after that for questions. So let's start. This is probably well-known bell curve describing the normal distribution of basically anything. And if we have it for the users of a software, then the average user is somewhere in the middle. And the line here is a software. And on the right side, from your point of view, it's too new, not well adopted, not tested, and so on. And on the left side is too old, obsoleted, full of flaws and full of problems and security bugs, etc., etc. And it's average, right? So my wild guess is that a lot of you is somewhere here in the middle, something which is still supported but well tested, not too new, not too old, and that's fine. The problem for us, RPM package maintainer, especially in Fedora and Red Hat Enterprise Linux, is that we are on the both ends of the both extreme. No software is too new for us. I will show you some examples. And no softwares are too old for us. I'll also show you some examples of that. Basically, the flow of the code looks something like this. That's, if you really don't know what does it mean to maintain an RPM package, that it might simplified look like this. So somebody creates a software, library, application, whatever. And on the other hand, there are users who want to use those applications and libraries. And in the middle is a magic man or woman, the maintainer, package maintainer. Because usually if you want to install some software, use it, you see it on the internet and, oh, this is a very nice application, I really want to install it. If you use a Linux distribution, probably your first step will be DNF search, yum search, apatus search, something, and you really wish the application to be packaged into that distribution, because it means that you can install it and somebody else take the care of all the stuff around it and compilation and testing and all stuff. And that's who we are in the Python maintenance, but not only in that one team, also in other teams as well. We are taking the code from upstream, creating RPM packaging, and delivers those packages into upstream, into our users, customers, and so on and so forth. I won't go much into the detail today. I won't be telling you about the commits and pushes and PRs and updates and here and there. What I will like to show you is what challenges you might expect if you want to be a RPM package maintainer. So I will use a couple of terms here. The list is short. When I say upstream development, I mean the development on GitHub, GitLab, somewhere, the upstream code, the people actually writing applications or libraries. When I say downstream development, I mean the development in the Linux distribution, the packagers who are packaging the stuff, writing spec files, and so on. When I say CVE, I usually mean some security flaw, security vulnerability. And EOL is a shortcut for end-of-life software without any more upstream support. So let's take a look. If you want to be a package maintainer, what's your responsibilities? You should try at least your best to keep your package functioning, which usually means that it should work, of course. It should be buildable from sources, so the process you described, how to build it, how to compile it, how to test it, and how to create the package from it, should be repeatable after some time, so it should be still buildable from sources. It should be installable. The fact that you have RPM package doesn't mean that it will work on your machine, right? So it should be installable and it should just work. It should be up to date. so you should update it regularly. You should fix issues and potentially CVEs. That's something I will describe later in the deeper detail. You should also try to limit the impact on other packages, which is something we'll also focus a little bit later. And you should try to limit the impact on the users, which is even harder than limiting the impact on other packages. But the best thing you can do as an RPM package maintainer is that you stay invisible. Like, if everything works, nobody knows about you, because they want to install software, they install it, and it works. Woohoo! I don't care who maintains it. It works. But if something breaks, then it's your responsibility. Let's start with some very, very simple example. The package name IOPing. That's a very simple utility. It can measure the latency of your hard drive the same way as the classic ping measures the latency of the network. That's it. It's written in C or C++, if I'm not mistaken. I'm in C, yeah. And it needs only 2 dependencies to build, GCC and make, because it uses make files, and it needs to be compiled, so it needs GCC and make, and only 1 dependency to run, glibc, which is the core of all the Linux distributions, so nothing you should be worried about. And no packages need IOPing to build, and no packages need IOPing to run, which means that this package is a leaf, so-called leaf package. If you imagine the tree of the dependencies of RPM packages, that one would be at the very bottom. Nothing depends on it, which makes the situation for you kind of, easy for the maintenance, because the probability something breaks for you is very low. Well, if anybody, moves the GCC from version 13 to 20, like that, then it might break for you, of course. But other than that, the probability that something breaks for you is limited, because you have very limited set of the dependencies. And the probability that you will break something for anybody else is also kind of limited, because no other packages depends on that package directly. So only if you break it, you might expect some bug reports from users. And that's something which is really hard to measure, because we don't know how many users are using the specific components, the specific packages. So what could go wrong here? As I mentioned, somebody can find a bug in the application. That might happen, of course, or security vulnerability. And the problem might be upstream, so in the code of the IOPing itself, or the problem might be downstream. You forget to package some files, or manual pages, or documentation, whatever. Or the problem might be on the left side of the previous image. So somebody update or change something, and it might break your package. Or you change or update something, and it might break other packages or the expectations of users. In that case, what to do as an RPM packager? Well, if the problem is upstream, the best way is to fix it, test it in Fedora, and propose the fix upstream. And we are doing it a lot. That should break the first kind of expectation, or that basically RPM maintainers just taking the code, packaging into RPMs, and giving it to users. But not usually true. And I will describe it a little bit more detail later. The problem is that in Fedora, we usually use the latest, greatest software, right? And that means that we are testing the software with the latest possible components of the dependencies, and that means that it usually breaks something, especially in case of Python. So we are the first ones who actually see the problem. So it's not just about, hey, I can report the problem, which is the second best thing you can do. I can just report it and wait for the upstream to fix it. And after that happens, I can just take the patch or the new release, update it, and it's done. Usually it's not. So the best way you can help as a package maintainer is prepare a fix. You can test it on Fedora, where the original problem appeared. So basically, the environment you want to test it is actually already prepared for you. The second best thing is report the problem and wait. That might be also valuable, especially if you understand the package and you can provide all the necessary details. I mean, all the versions of dependencies and configuration flags and compilation flags and all the details around. That might be really helpful for upstream. And by doing that, you might actually make upstream to fix that problem very early for others. So you uncover a problem, you fix it, report it, and those might make that no other users on the bell curve in the middle will ever know about a problem being there at all. Or you can do nothing, which is bad. If you have broken dependencies, then the first point is the same as a bug or security vulnerability. You just need to take your software and adapt it to the newer version of your build or test or runtime dependencies, which might be a little bit hard. Another thing, if you are very lucky and somebody is moving a package to another major version, like switching from GCC 10 to GCC 20, for example, if you are lucky, they are aware of you depending on the GCC 10, and they might create a compat package for you, which means that you can switch the build dependency and say, okay, for now, I'm fine. I have to take a look on that because the GCC 10 won't be there for a long time, but right now I'm safe. Users can still use the latest version of IOPing, but I have to think about it. But honestly, that doesn't happen so often, so you have to switch your package to the latest version of dependencies. And of course, if the problem is downstream in your package, then it's your responsibility, right? That might sound like a lot of work. Does it? That's nothing. Not yet. We are not there yet. Let's move to the other side of the problem, because we have a cookies. Oh, not actually cookies, but we have a lot of stickers. So after the talk, I will give you some stickers. So let me step aside for a while. I will describe in more detail what we do in Python maintenance team, especially in Fedora. Fedora loves Python. Almost all of them, Python 2.7 not that much, but still. And we would like the Fedora to be the best distribution for Fedora developers at all, and for Python developers at all, which means that we maintain multiple Python interpreters at the same time, continuously. For some of them, mainly because we have to do the same in RHEL. And that means that if you want to develop a Python application for RHEL 8, or for RHEL 7, or for RHEL 6, or RHEL 9 and future 10, then you can use Fedora for that. You don't need a virtual machine or anything virtual with the old distributions and stuff. You can take Fedora, take the Python, whatever version you want. You can create a virtual environment for that, write an application, test it, and it's all great. If you are on the other side of the bell curve, as we are sometimes, then you might want to test your application with the latest, greatest version of Python, which is also possible. We have Python 3.12, which is now first beta, but we have it in Fedora since first alpha, which means that you can really test with all the supported Python, and we support a lot of them much longer than upstream. And also we have some alternative interpreters like PyPy. We had also Jython, but no anymore. And also, we are very fast, really. It took us only 7 days for 3.11 Alpha 1 to appear as a build in Koji, which means that if you really need the latest, greatest Python, there is absolutely no need to compile it from sources from you. And that's really, really good. Only 3 days for first beta and only 3 days for 3.12 Alpha 1 after it was released upstream, it appeared in the build system of Fedora, and you can use that, which is quite awesome. And what's maybe more important than that is that these are much faster than the usual CI providers. You know that you can use Python for testing on GitHub Actions and Travis and Circle CI and whatever, but you will wait months after the official release of Python 3.11 or 3.12 and the future. You will have to wait months after the official final release to appear in the CI system like those. You are not a Fedora user? Shame on you. But it's not a problem. Because we offer all the Pythons, including with the talks, which is a great tool which enables you to test one application with multiple Python versions, even in parallel if you want to. So all the Pythons talks based on Fedora as a container image, available on Docker Hub, and also as a GitHub action. So you don't need to use Fedora directly. You can use it only in the CI to test with all the supported Python versions. All right, but the situation for most of the interpreters I mentioned on the previous slides are the same as for the IO ping, because the alternative versions are basically the leaf packages as well as the IO ping is, because nothing should really depend on it. They are not meant to be used in production. They are meant for development and testing. But there is one, the main one, the main troublemaker. And there is only one in every Fedora release, which is the main one. It's basically usually the latest stable release of Python. And that's the one which causes us the most troubles and most work at the very beginning of the Fedora release. Because all of those are usually leaves packages for testing and development, that's fine. That applies also for the future versions, but the main one is the troublemaker here. Let's increase the complexity of the example with IO ping a little bit. The grab for Python 3.11, which is the main Python interpreter in Fedora 38 and Fedora 37, looks like this. We need 45 packages to build it. We need 24 packages to use it. And by use it, I mean the Python interpreter and its standard library, not all the components provided by that package. But that's the part we really cannot affect, right? Something might break here, and the probability on the left side of the image is much higher than for IO ping, because those packages are much more complex than GCC and Make, and the numbers are just really, really higher. But the funny part begins on the right side. 4,400 packages needs Python to build, and 5,600 packages needs Python to run. It's like, wow. So, okay, what we can do, we can bump a version, build it in Koji, right, and release, and do whatever you have to. Fix it for yourself, let's say. That's obviously something we cannot do, and that's the reason why it generates so much work for us. The reasons are basically two. First one is that the newest Python releases, or every Python release usually contains some backward incompatible changes, like removed the deprecated modules. Because when developers see a deprecation warning for 2 years or 3 years, that's not enough. So when the module disappears from the standard library, then a lot of packages or a lot of tests and stuff like that starts to fail, right? That's acceptable. So there are some backward incompatible changes, and also one more problem is that Python is interpreted language, and that's true, but a little bit of that is compiled, let's say, and that compilation process creates the PYC files, which is basically a cache version of imported modules. The problem is that the imported modules, the PYC files, are written on the hard drives to the locations where only root or super user can access, which means that we have to ship those files in RPM packages, and that means that those are installable only by root. So if a user imports a module and the Python tries to create the PYC file somewhere it's not possible, then it won't happen, right? And the compilation step would be doing the same again and again. And that means that we need something called mass rebuild. But that's somewhere in the middle of the update process. The first step of the update process is write a change proposal, right? You can see those on the Matthew's talk today. So write a change proposal, describe your plan, describe the contingency plan, and so on and so forth. Then package a new Python version as a new package. We cannot just update the old one because we want to maintain it, so we want to keep the old version, so we have to create a new package. and then rebuild the thousands of packages in Copper. Copper is just, let's say, an alternative build system we can use for testing. And during those rebuilds, you will uncover a lot of bugs. Some of them you can fix, some of them you cannot. You have to report the bugs upstream of the libraries, downstream if it's a packaging problem, upstream of the CPython itself, because we are just humans, right? And Python is just a software, so full of bugs as well. Or downstream, fix it downstream in the package, Python packaging as well. So really incredible amount of work, and it usually, the whole process I'm describing here, which usually takes the whole year, because Python releases are somehow aligned with the Fedora releases, which means that fall this year we expect Fedora 39 and also Python 3.13 Alpha 1, and we will have the whole year to prepare the Fedora packages for the new Python version. Rebuild all the packages in the side tag again. The side tag is something like a branch in Git, nothing to be really worried about. So we prepare all the packages we know about, all the problems we try to fix in Copper, and then we can rebuild them again in the side tag of the development version of Fedora on Rawhide, which is actually happening right now. The process of rebuild in the side tag started a couple of days ago, and we are somewhere around 3,000 of packages already built. And then you merge those rebuild packages back to Rawhide, and ta-da! You have the Python, in that case, 3.12 in Rawhide, and that's awesome, right? It's incredible amount of work, and thanks mostly to Tomasz. You can talk to him after that. Tomasz, raise your hand. Tomasz is doing incredible amount of that work through the whole year, maintaining that process. It's incredible. And some numbers. 3,361 packages in Copper, almost 50,000 of builds, and just almost 5,000 Bugzilla. And those are just bugs in Bugzilla. I'm not talking about all the GitHub issues and GitLab issues and so forth. So in Fedora, updates are really complex, and you have to be really careful because you can break all other packages or a lot of system tools, which is case for Python, because a lot of things really in a system depends on the Python itself, like the installer, Anaconda, and the DNF version 4. The 5 is not longer in Python, but the older version is. So you have to be really careful. But the benefit for the updates is that it usually fixes the security flaws for you and the bugs. So if you cooperate with upstream, it usually don't take that long to release a new version of the upstream project, and you can update in Fedora. You don't have to backport patches, you don't have to make your own fixes and so on. You can, but you don't have to. And you can do it in a similar way as we do. You can assess the impact of the change in Fedora if you want to. And if you are interested, stay here in this room, and Carolina will tell you more about how we do it in Copper in a little bit more detail. But let's move to the other side of the bell curve. What if we cannot update? What if we cannot change it that much? That's a problem we have to solve in RHEL. The promise for RHEL customers and users is that we will try, I added the try mention, we'll keep your system secure without breaking backward compatibility of provided components, which means that the updates are usually out of question, usually, not every time. And I would like to describe that on 2 security vulnerabilities we had to fix and how we deal with that on multiple levels to show you that it might be really interesting and also really complex when it comes to fixing something in older components, in the old systems for the customers who depend on the maximum stability. Let's take the first one, which is a web cache poisoning in URL-lib, which is a standard library of Python. And the problem is that when you have a URL address here, it's usually parsed somehow by proxies or web application and so on and so forth. And you have to set a delimiter for the key value pairs here. And World Wide Web Consortium recommends using the ampersand only, fine. But the Python had semicolon and ampersand both at the same time as a default. All right, that we don't need to go much deeper into the detail. The thing is that if the application is configured differently than the proxy in front of that application, it might mess up the results in the proxy, and that's what the vulnerability is called web cache poisoning. Okay? So, right, what we can do, we can follow the same recommendation, right? And that's exactly what upstream did. All right, recommendation is to use ampersand. Well, switch the default to the ampersand. That's too rash, you know, that's too rough. We have to find somewhere middle ground. All right, let's switch the default to the ampersand and allow users to configure something else. That sounds great. But the separator keyword argument added into Python don't allow you to use more than one character. So you have to choose either the ampersand or the semicolon or whatever you want to, but not multiple at the same time. And that's a problem, right? So the Fedora, we are latest, greatest, whatever it means. So we just followed the upstream resolution. We updated all of our Pythons because the fix was kind of quick. So it was implemented upstream. They did security releases. So we just updated all our components. And for the AOL interpreters, which are maintained by us and not upstream anymore, we just backported the patch. So Fedora follows upstream, and the new default is the standard, and that's what it is. Deal with that. But for the RHEL, we cannot do that. That's a problem. So we basically took the patch from upstream, adapted in a way to allow the old behavior by default, and added a warning. So if you use that default, so which means that your application is not ready for the new code base, if you use that default, somewhere in your log will appear a warning with a link to the documentation, and the documentation will describe to you what's happening. But after that, we still cannot expect our users to change their code base. So we have to find a way how they can set the new default without actually changing their applications. So in the patch, in the same thing, we have provided a way in the Python code itself, which is kind of obvious, but we also provided a way how to set it via a configuration file in etc, and also a configuration via environment variable. So we didn't change the default behavior. We added a warning to our customers saying, don't do that, please. Because on the other hand, they might use the default for Python, ampersand and semicolon, and they might have some old proxy configured in the same way, and everything is fine. And if we would change the default, it might silently break a lot of stuff. Silently, that's a problem. So we added a warning. We added the possibilities how to configure that, so everybody can do that on any system, setting variable, adding a file into HCC, and whatever. So we had to be very careful, and in that specific case, we have decided to not change the default setting. Another CVE, and the last one I would like to talk today about, is the tar file module directory traversal. And if you know that the second part of the identifier is a year, then this one is waiting for a fix for a long time, really. I've tried to say to Peter, like, hey, we can wait couple more years and then we can celebrate the 20 years of that CVE and fix it, right? That would be great birthday gift, but no. Peter decided to fix it this year. And we are actually in the process of doing that, so I will describe that. So the problem of a tar is that it was designed to back up the whole systems completely, which means that it supports symlink, hard links, extended metadata, some special files, relative paths, and a lot of stuff. The problem is that if you unpack an archive from an untrusted source, it can completely break your system, really, which is not something we would usually need these days, right? We are no longer backupping our system on the tapes, magnetic. So that was it. But then there's a problem. What's the correct way? How to do that? And the upstream had the perfect resolution, to nothing. We said in the documentation that blindly extracting archives is a bad idea. You should, now I feel like in a church. Extracting untrusted archives is a bad idea. You shouldn't do that, and you should inspect the archive before you extract it blindly. All right, that's true, documentation said that. But the problem is that still the best place to fix it is in the tar file module. The best, I'm going to be pushed from the stage. No, I 2 more minutes, please. So the best thing or best place to fix that problem is really into Python. Even the documentation says that everything is correct in the Python. So Peter, my another colleague, Peter Victorin, decided to change it into Python, but it cannot be done in a backward incompatible way, right? So he wrote a PEP 706, which is Python enhancement proposal, really long document, full of useful information if you wanna read that. And it added filters to the tar fully trusted, which means that you know what you are doing, tar somewhere in between, and data, which is the safest one, only allowing some capabilities of tar. Python now have a deprecation period in Python 3.12 and 3.13. The default is the same, but there is a warning if you use that default. Same thing as the URL lib. And then in 3.14, the data will be the new default, which is how it works in Python. So in Fedora, we basically followed the same thing and backported the patches into the ALL interpreters. So now all of them behave the same way. And in RHEL, we have decided to do even more strict thing, and we backported the patch and set the strictest filter to be the default one in the RHEL distribution. So we can finally say that after many years, the vulnerability is finally fixed. And that's one backward incompatible change we had to do, and we will see what it will cause. So, some conclusion, I know. Some conclusion, being a package maintainer might mean a lot of things, a lot of different things for a lot of different people. If you wanna maintain a leaf package with a useful utility, please do that. It won't cost the whole free time you have. But if you want to maintain something like Python in Fedora and RHEL, be prepared to sacrifice something. And in Fedora, it's good to know your packages, because if you do so, you can prepare patches, you can help upstream fix the problem. If upstream is no longer interested in their packages, you can maintain them, you can help to evolve the whole ecosystem, or at least create reasonable reports. In RHEL, you have to. You really have to understand your package, the packages you have. You really have to be able to backport patches 10 years down the road to the very ancient component, open the book full of dust and backport the patch into that. So you have to really know what you're doing. And you have to be prepared to do some tough decisions like we did when fixing the vulnerabilities. All right, and that's all. Thank you for your attention.
Now is the question time. We have 2 minutes. So, yeah, please go ahead.
So I saw that there were more packages depending on Python listed on one of the first slides, and then less packages built in the core. Why?
Because I repeat the question. Why we have in Copper less packages than actually depend on the Python? That's a great question, and you you actually look at the presentation. That's great. So the reason is that we follow the dependencies between those packages, and we don't try to blindly build everything. We first prepare the dependencies for all the packages, and then we add them. So it means that we weren't able to build all of them in Copper, and we have to start the side tech rebuild, which means that some of the packages weren't in the buildable state, so we didn't add them to the Copper because not enough dependencies at that time. Thank you for the question. Well, the question is whether we try to discover runtime issues with the new Python. That's a great question. And honestly, the amount of work we have with the build time is a lot. So there is not that much time to do so. But we really think that every single RPM package should contain tests. So we really depend on the components, depending on Python, to have some tests, which kind of means that we should be able to get them, to get the problems in the runtime. But yeah, if the package has no test, there is no way to verify it works with the new Python. Yes, yes, unit tests mostly. Because during the build, in the build system, there is no access to the internet, so no that much of integration testing and stuff, but every single package should have a check section with a unit test. And if we rebuild the Python and then rebuild the PyTest, we hope that PyTest has as good coverage as possible, so it will, you know, uncover some possible problems.
Okay, we are out of time. So
And I'm sorry for that. Thank you.
to dobrý?
Thank you very much. Hello, everyone. My name is Karolina Surma. I work at Red Hat as package maintainer. I do a lot of package updates in my daily work, most notably Python Sphinx, which is a quite popular documentation tool, which has got over 1,000 dependencies. And every time I want to bring a new update of Python Sphinx to Fedora, it means that I'd like to be pretty sure that this update will not break anything. Lumir has provided a lot of context just in the previous talk why it's important. So if you haven't been here, make sure to check out later the Lumir talk. And the process I'm using in my daily work, I'd like to describe here today for you. This talk is going to present a very practical approach. I'm not going anywhere deep in my explanations. There's no time for that. It's going to be applicable immediately for Python packages and for packages that are built from our languages, maybe with some tweaks. I'm not very familiar with anything else. But we can talk about it later in the social event. The projected audience for this talk is me 2 years ago when I started my journey as a package maintainer. And I really needed a lot of context in order to be able to do my job. So how does this typically look like? There is an upstream project developer, someone who creates a really nice library. They create a new version. Me, as a package maintainer, somehow get to know that there is a new version available, that it would be really nice to bring it to Fedora, Rawhide, because this is where the newest, freshest, hottest things should go to. It's the developmental version of Fedora, a really good place to land such updates. And that's it, right? I package it, I push it to Rawhide, build it, I'm done. Well, this is the place where a decision can be made. I can either do that and do it just like push it to Rawhide, I build it locally, it built, great. Or I can just step for a moment and think, maybe I could leverage Fedora quality tools that are available in the ecosystem. And what would be that quality tools? In a very simplified manner, and please don't quote me on that, because I have no idea how the Linux distribution is built, really. Distribution like Fedora consists of many RPM packages. And in the ideal state, those packages are buildable and installable. Unfortunately, that's not the case for all of them, but we aim for that. And in order to ensure that the update I'm bringing to Fedora is buildable and installable, I've got some local tools that I can use, which is mainly mock, or I can build my update in container, or I can leverage Fedora CI. Fedora CI does scratch builds and runs any tests that you have with your package in the Fedora dist-git. And there is Zul CI, which does everything Fedora CI does, plus much more. So if you're going to leverage Fedora CI, go for Zul CI. With the only disadvantage that it will take some more of your time, and it would be best if you just opened a PR pull request to your own package in order to get any failures before you bring them to the distribution. But it's not only about the particular RPM packages. When we create the distribution, the whole point of creating a downstream distribution is that the packages actually communicate with each other. They play with each other nicely, which means I can build my package on top of the other Fedora packages, and I can use my package to build some other Fedora packages. Also, again, Lumir has got a great graph showing exactly that. And for that, for checking the integration, we've got a process we called impact check. In Copr language, it's called mass rebuild, and you can think of it as an integration test pretty much. While the CI is more of a unit test, it takes care of the health of one package. Impact check makes sure that no other package stops being buildable when you bring your update to Fedora Rawhide. In Copr language, Copr is a build system. It builds packages. Its main usage is not how we are using it. We are creating a lot of Copr repositories with throwaway builds. And in Copr manner, what I really want to have is this last build status succeeded. This is the only thing I care. So the process looks like that. I create a new isolated Fedora, virtual Fedora. I bring my just updated package to that Copr repository, build it, and then take all of the other packages that depend on my package and build them. If they all build, I'm happy. Probably my update doesn't break anything. If there is something that failed, and I really don't like that red journal there, HTTP, sorry, then I should investigate and take a look at it. So in order to show you this process, I took Python-rich library. It's a really nice library to build text user interfaces. And the authors of that library and the maintainers of that library in Fedora didn't do me anything bad, so they don't deserve what I did to their package. I just removed the emoji module. I just prepared a downstream-only patch which removes one of the modules the package has. It's a silly update. It's just something I did downstream. The upstream developers wouldn't probably agree with me, but it's not so far from the truth. Many times it happens that when you have a major version coming from upstream, it contains a lot of removals or renames and some incompatible changes. So it can, and it does happen. And I can still have some packages in Fedora that rely on this emoji module to be available to build and to run. So I'd like to know whether there are any and which one and what happens there. I've got 32 packages that require Python free reach on build time and 22 packages requiring Python free reach on runtime. Copr is a build system. I don't have any means to check the runtime thing unless those packages have upstream tests. If they run the upstream tests, they should pull the runtime dependencies in the build time, and then that would increase the visibility for me. So the question I'm left with is how many of those packages, those build time, those packages that have Python reach on build time, will just stop to build. So the greatest catastrophe that can happen is 32 failed packages. To start, I assume that each one of you has already done the Fedora packaging tutorial and has got installed the basic packages. In this process, I will use tools that come from Fedora repository, some additional ones. Fedora packager contains pkg name, very nice tool to get just the package name from the whole RPM name string. Fedora repos rawhide contains repositories I can query. I don't want to install packages to my system from rawhide. It wouldn't be a good idea, but I want to query through the RPMs and the metadata. There is a nice binary Copr CLI to enable me interaction through the command line so that I don't have to click on the web interface of Copr. And more utils parallel comes with a binary parallel to speed things up. If I want to send 1,000 builds to Copr, I don't want to wait consecutively one after one. The really great tool that comes with DNF is repo query. It's complex and it can do a lot of things, and it probably deserves its own talk, so I'm not going to go into repo query and what it can do. The basic command to query the repositories is just as follows. With the first command, you will list all the RPMs, all the build RPMs that are in the rawhide repository, and all the source RPMs that are in rawhide-source repository together. -q is an option to suppress the metadata check, which is not something I'm interested in. So all the commands have this optional -q. For a released Fedora, the query is a bit different, so I just put it there for documentation purposes, but I will only continue with rawhide. So first question, I need to know what gets built from my package. I already told you that I just destroyed half of the Python rich package, but I'd like to know what is the build RPM, what is the name the other packages will depend on. In Python case, the convention is that the source RPM are not versioned, so I have Python-rich, this is the name of my Fedora component, but what gets built is Python free-rich. And this is the name I'm going to use in the following commands. There can be multiple build RPMs coming from a single source RPM, and in such case, if you'd like to do an impact check, you should probably repeat all the following commands for each of the build RPMs that come from your source RPM. any other, like other packages can depend on any of the build RPMs that come from your. I will not dig into that too much. Build time and runtime dependencies. For the Python world, the same invocation. If I want to know what Python reach requires in build time, I need to query repository with the option -- requires and provide the source RPM name. There can be the full name of the RPM. And what I get is the full list of build time dependencies. If I'm interested in the runtime dependencies, which for the purposes of this talk I'm not, I would invoke the same command with the build, with the name of the build RPM. It's significantly smaller, but also I can see that the runtime dependencies are listed in the build time dependencies. So my package pulls them and probably tests with them. So I'm fine here. Yeah, let's go further. Okay, so back to the build time dependencies. I want to know what other packages require my library Python reach to build. I already told you that the answer to life, universe, and everything is 32. But how did I know that? There is the commands, of course, like for everything, the repo query, that will tell me. There is the option -- what requires, which takes my build RPM as an argument recursively, so that I can get the full impact, the full picture of what would get broken if I really pushed the update to the repositories. And I'm interested in only in the source RPMs, which are the ones that expose build time dependencies. Those are the ones I can check in Copr. From all of the results, I will pipe them to the pkg name tool, and this will tell me only the package names. So if I run the same command, you can see that it gives me something, and if I make my bash count that, it's 32. This is what I want to build on top of my update in order to assess the sanity of my changes. Knowing that, I can go to Copr. Anyone can use Copr. You only need to have FAS account, Fedora account system, and API token, which you can easily get from the Copr Fedora infracloud.org /API page. Once you're set, we need to do those 5 steps I mentioned at the beginning. So we need to create a new Copr repository, add and build our package with the update, add and build all the other packages. First of all, I did all of those steps just before the talk so that I don't clutter our time typing those beautiful commands in my terminal. But we will go to the live demo with the results. So first of all, I define a handy variable only so that I can reuse the commands every time I do a new impact check, and I do them a lot. Creating a new repository means that I need to invoke Copr binary with create argument. It takes another argument name of the Copr I want to create. I want to create it for rawhide. I don't care about architecture really, because Python packages are mostly no arch, but it may be different for your case. There are different roots. There are also not only, you can also build RPMs for other systems, not only for Fedora using Copr, so it's really universal. The important thing is that I'm adding a new repository to my Copr repo. It's not only looking at Fedora rawhide, but also to Koji. Why is that? There is quite often a little bit difference between what's in the rawhide repo and what's in Koji. Packages change all the time. You can start working on it, and the state in which the repository will be 20 minutes later will be completely different. So sometimes it's like some changes sit in the Fedora repository, but the maintainer deliberately or by mistake forgot to build it. So we are grabbing the latest changes, the latest packages, the latest versions from Koji in order to test on the hottest, freshest, newest. And because this is a throwaway repository, I'm not going to keep it forever. For small updates, 14 days is just enough. So I'm deleting after 14 days or 30. Only big updates require more time. Adding the package. I already conveniently destroyed my package and sent it to, okay, I know what I did. Send it to my fork of Fedora dist-git. So it's there sitting in the branch DevConf. I can add that package. I can tell Copr that I want to add it from the source control management system. So for that, I have an argument add package SCM. And again, to which Copr, what's the URL where my package sits, what is the branch name where I pushed the update, and last but not least, the name of the package I want to build, which is Python rich in my case. I didn't have to go to my fork of the package. I could only build my local source RPM, but then I would not, it's easier for me to switch any automation I would like in order, if I wanted to tweak with my package and push new changes to my fork, then Copr has the ability to pick them automatically. When I have added my package to Copr, I should build it. For that, I have a command Copr build package, where and what. And now I should wait. This is an important step. I should wait for my package to build successfully and only start pushing new packages for that when it's ready. If I do it too rapidly and the package will not be yet built in Copr, the Copr will have no problem with going for my Python reach from Koji repository or Rawhide repository, and I will not test at all what I wanted to test. So provided that my package actually built and it built successfully, if it didn't build successfully, then I need to repeat it so long as it actually builds. Otherwise, I will not test anything again. I can use the utility called parallel to speed things up. And another great feature of Copr is that it can allow me to add packages directly from the dist-git, and if I don't specify which dist-git, then it means Fedora dist-git. So I'm adding packages that are sitting in Fedora dist-git, all those 32 packages, to my previously defined Copr. I want to switch on the webhook rebuild. It's really nice piece of automation I just mentioned before. I didn't call it like that. Anytime a package maintainer, any other package maintainer does a change to their package while I'm doing the impact check, while my repository is on in Copr, the Copr will automatically know that there was a change of state in the Rawhide repository and will automatically rebuild the newer version for me. So I don't have to think that, oh, I did my impact check 2 weeks ago and it's probably stale now because the packages move so fast. My Copr will pick it up. And another argument, --name, another option, I need to provide to the command all of the packages that require my package on build time, which is basically, again, the output of the command you've already seen, piped to sort and unique just to be sure that there are no duplicates. There shouldn't be, but it doesn't hurt. Last step of the process, building the depending packages. Again, using parallel to speed things up, I can send to parallel the command build package, and it looks very similar with some new options. So no wait, --no wait is an option not to clutter my terminal output. I will not have to wait for each build to conclude in order to be another one to be sent. And the factor of niceness, background. Copr has got different queues. There is a normal queue for normal packages, and there is a queue that gets populated in the background. So when someone has got a priority work, they should probably use the main queue, but impact checks are rarely that important. So it's only nice for the other users of Copr not to clutter all of the available workers with my 1,000 packages that I will just remove when I see that they built successfully. So background is really nice option, please use it. And again, I need to tell which packages I want to build. So this is my magical invocation. When this all happened, my biggest question is what failed? This is what I really want to know. Maybe nothing, that would be great. Maybe something, that's not so great. With Copr, I've got another handy API to interact. There is a monitor. Each Copr has got information about its state. How did it go? If I just run Copr monitor like that, the output will be provided in JSON, which is not so nice to interact with from my command line. So I can tell that I want my report as a text row, and I only care about field's state, whether the build succeeded, and the name of the package that succeeded or not. And in this case, I'm only interested in what failed. If I do that, I hope it will work. Yes, there are 4 packages that failed in my Copr. That's not too bad. I could go through the build logs of all 4 of them, but it can easily happen that I have 10 or 20 or 60 packages that failed. My Python interpreter colleagues would have thousands of packages that failed. It's not that nice to go through the build logs. What we often do, we use that command to create another control Copr. And I have the habit of naming it completely the same with the dash control in order to speed up my typing kung fu. So with that control Copr, I would rebuild only the packages that failed in the first Copr to look for false negatives. This could look pretty much like that. So provided that I got one Copr repository with failed packages, I created a new one, control repository, which rebuilt only those failed packages. And from those, I'm only interested in those packages that actually succeeded. This is my diff. This is my difference. What failed in the first one and what succeeded in the second one. If the list is long, then I can use another Linux utility, com, to compare the both results. In my case, it will not be that bad because I've already done my Copr control just before the talk, and now I see that there is only one package out of those 4 that actually succeeded in the Copr which did not contain my update. So this is my problem. This is my culprit. This is something I need to really look at. So that's the process. And now we come to results evaluation. And this is for now a manual step. All of the steps I showed you can be somehow automated. You can write bash scripts. You can even script opening your browser with logs from the command line. It all depends on the workflow which you are used to. Each one of us in our team does it a little bit differently, so we don't even have one process for all of us, but we have automation to some degree. In my case, I will just go to Copr for the moment. I'll show you the most mundane thing that can happen. So I'm in my DevConf prep, which is the repository I was doing all the work before the talk. I will find packages. It was Python typer that I'm interested in. Oh, it actually failed. Not that I didn't believe the CLI, but it did. There's a lot of builds, and they all failed. That's not a good sign. It's not probably just a flaky package. You can see that my build was running in the background. And there are the logs. There is the chrud, this is the rawhide build, which failed, and there are the build logs that I'm interested in. What gets open is a really nice build log. Everyone who built a package knows them by heart. And I'm, of course, interested in whatever is at the end of the build log. And I see that some tests failed. And when I start looking at what failed, it's like emoji has no attribute replace. Remember what my update was about? Oops, I've got it. So this is something I would not know if I just pushed my update to rawhide and be happy about it. This is an actual problem that I would introduce as a package maintainer who didn't care about all the rest of the ecosystem. But right now, I'm looking at it, and the real maintainer of the package Python typer doesn't know about it. They have no idea that this is going to happen. How would they? Like, they are not going to actively go through all the packages their package depend on. So when I'm looking at that, at this point, I'm the most competent person to actually do something about that. And the bare minimum would be talk to the maintainers of Python typer and tell them, like, heads up, hey, I'm going to bring this update, and this is going to break your package. You can do it by any means possible, maybe opening a Bugzilla ticket. If there are more packages than one, if there are 10, 20 broken packages, and you don't know exactly what to do to help all of them be, again, buildable, you can write to Fedora Devel and say, OK, I'm bringing this update. Those are packages that are going to fail. This is some guidance I can provide. But please, in a week, I'd like to merge it, and maybe you should take a look at it. If I'd have 60 packages that fail after checking my impact check, that would be a good material for a Fedora change. So increase the visibility of the issue. And if I'm preparing a really big update, then most of the time I've read the change logs, and I know, or I can find, I'm in a better position to find a migration path. So I can help from just telling the maintainers, reporting it upstream, fixing the issue upstream, downstream, increasing visibility, to providing some guidance. Like, I can pick from a big variety of activities in order to help make all of it smoothly. And seeing that we are coming to an end, I just wanted to tell you about one big copper gotcha. Some packages are quite aggressive when it comes to dependency version constraints. And they say that this package only will work with my library, which has a version lower than 14, for example. My update doesn't bring such version bump, but if it did, I would expect Copr to say, OK, I have Python free reach 15 built in Copr. This package requires Python free reach lower than 14. So we are not meeting the condition, so the build fails. That is a very reasonable expectation, except in Copr, it would not work. It would be false. Copr has got no problem with skipping my just build version with update and going to Koji or Rawhide and take the version of the package of the dependency that it needs. And in order to mitigate that, there is this beautiful shell snippet that will go through all the dependencies, all the packages that require my library, and check whether they require my library with the lower than character. And if they do, it will print them out. And in my case, Python reach, I will not show it, it's a bit slow. But actually, there are 2 packages that require Python free reach lower than 14. And that would be, again, my big candidate to reach out to the maintainers of the respective packages and tell them, hey, your packages will stop being buildable, installable, and usable when my update reaches rawhide. Okay, there are some further resources. This is a piece of a tribal knowledge that my team has assembled. We are trying to write it down and prepare it for further generations. So the impact checks are described in our pull request review guide. Also, Copper has got very usable documentation about the mass rebuilds. And this presentation with all the code snippets can be found on GitHub. This is it. Thank you very much for your attention. So if I have any idea how we could speed up things when it comes to the browsing the build logs, well, it is yet to be done. The actual build logs, I will show you. I will not. Okay, so the URL is, I can't. Okay, so the URL is divisible. I only need my Copr name, the build number, the package name. So I can get all of it from Copr Monitor. I can automate creating this URL where the logs sit. Then I would need to download all of these logs and somehow assess how much of this output I need to take, and maybe provide some automation of results, some aggregation of results, whether a certain string is found, so that I don't have to just go through 10,000 logs, but in some nicer place. So yeah, it's something that can happen, but it didn't yet. Maybe my colleagues have some ideas. Some AI engine could do it. So yeah, maybe this is what will solve all of our problems. The issue is that like the outputs of the failed logs can be really weird and different. Sometimes we need to grab more context. It's moot to go through the logs of packages that don't build for half a year, because probably their failure is totally unrelated to my update. It's definitely doable to some extent. I don't know to which, and none of us had actually much time and cycles to do it. So maybe this is waiting for some really brave community folk who would just come and solve this problem for us.
So right on time, and I guess we can have another part question. Please go ahead.
I'm sorry, I hear you really badly, so I didn't even grab the core of the question.
Basically, my question is, this way of detecting issue in the package using the package we maintain, it works only if the tests are part of the build process, but not if they are implemented in external tools like TNT in the case of Fedora. So it's just a remark.
I'm sorry, I still didn't get the question. Maybe we can talk about it later when I can actually hear you. Thank you.